students. So, in our series of crash course, today we are going to study organic compounds containing oxygen. This is day 32 of our crash course. This is disclaimer. So, this is the analysis of the chapter in JEE exam. Between 2017 and 2024, a total of 10 questions from this topic have appeared in JEE, showing consistent inclusion every year. This steady presence highlights its importance in the exam pattern. The overall weightage stands at 4.16%, which indicates its relative share among all questions. Thus, students, you should not overlook this area because it contributes to the exam each year. Now comes the yearly question distribution. From the year 2021 to the year 2024, questions on carbonyl and carboxylic compounds have appeared consistently in JEE with a steady focus on their physical and chemical properties. In the year 2021, topic area covered was properties of carbonyl compound. Concepts included were aldol reaction or reduction with NaBH4. One question was asked and it was average. So to solve this type of question, our key focus area should be on aldol reaction and reduction mechanism. In the year 2022, topic area covered were properties of carbonyl compound and concept included physical properties, chemical properties, aldol or cross-aldol condensation. Two questions were asked and they were average. So to solve this type of question, our focus should be on properties and aldol condensation reaction. In the year 2023, topic area covered were chemical reaction and concept included addition of HCN, Clemmensen reduction, tolerance test, reduction to alcohol using LiAlH4, Grignard or aldol condensation. One question was asked and it was average. To solve this type of question, our focus area should be on various reduction and addition reactions. And by 2024, the spotlight shifted to carboxylic compounds, testing both physical and chemical aspects. Overall, the difficulty level remained average, but the recurring presence of these topics showed their importance in reaction mechanism and properties. So this is the further extension of the table. So continuing the analysis, the years 2017 to 2020 show consistent coverage of aldehydes, ketones and carboxylic acids in JEE. In the year 2017, the focus was on Grignard reagent, addition reactions with a relatively difficult level. While in 2018, there was not a single question from this area. The trend resumed in 2019 with two questions emphasizing preparation methods, oxidation reactions, and acidity order, marking a mix of average to difficult levels. By the year 2020, the spotlight shifted again to preparation techniques and reactions with Grignard reagents, maintaining an average difficulty. This continuity highlights the recurring importance of reaction mechanism and preparation methods across these years. Now, before starting with the lecture, let's have a look at the topics we are going to cover today. So, at first, we will learn about alcohols, then their preparation, then reactions of alcohols, then we will learn about identification of primary, secondary and tertiary alcohols. After alcohol, we will discuss about phenols, preparation of phenols, followed by reactions of phenols, and then at the end we will discuss about ethers. First, preparation of ethers and then their reactions of ethers. So in this lecture we are going to discuss about alcohols, phenols and ethers. Alcohols are formed by the replacement of hydrogen from aliphatic hydrocarbon with hydroxyl group, that is OH group. And phenol are formed by the replacement of hydrogen from aromatic hydrocarbon used with hydroxyl carbon, OH, hydroxyl group, sorry. And ethers are formed by the substitution of hydrogen in hydrocarbon with alkoxy or araloxy group, that is OR or OAR groups. So here we are going to learn about the structure and preparation of alcohol. So what exactly is an alcohol? An alcohol contains one or more hydroxyl or OH groups. These OH groups are directly attached to carbon atoms that are part of an aliphatic system, which is a straight or branched carbon chain. For example, in methanol, chemical formula of methanol is CH3OH. So in methanol, we have a single hydroxyl group, that is OH group, attached to a methyl group, which is CH3. Now let's talk about preparation of alcohols. Alcohols can be prepared by following methods. First, we can make alcohols from alkenes. So alkenes, which contain carbon-carbon double bonds, they react with water in the presence of an acid catalyst to form alcohols through a process called acid catalyzed hydration. So here we have a reaction of 3-methyl but1ene. So as we can see in the diagram, how the double bond of the alkene is broken and a water molecule is added across it. During this reaction, an intermediate carbocation is formed. And this carbocation can then rearrange to form a more stable carbocation. If rearrangement is possible, then carbocation undergoes rearrangement. And because the reaction follows Markovnikov rule, which states that the hydrogen gets attached to the carbon which contains more hydrogen. So the OH group attaches to the carbon atom that is more highly substituted, and hydrogen gets attached to that carbon which is less substituted, which contain more hydrogen atoms. So acid catalyzed hydration of 3-methyl but1ene result in 2-methyl 2-butanol, not 3-methyl butanol, 2-butanol, because of the rearrangement of carbocation. Now we are going to learn about oxymercuration, demercuration reaction. So in oxymercuration, demercuration reaction, we first treat the alkene with mercury 2 acetate, which is mercuric acetate. The oxidation state of mercury here is +2. And this reaction happens in the presence of water. This forms an intermediate called a beta hydroxyalkyl mercury 2 acetate. We then immediately treat this intermediate with sodium borohydride, that is NaBH4, to produce alcohol, the desired product. So the intermediate formed here is 3-member mercurinium ion, which is a non-classical carbocation. And on that, H2O attacks on the highly substituted carbon, and then we reduce it using NaBH4 to produce the alcohol. So here we can see the OM-DM reaction, which is oxymercuration-demercuration reaction. It involves treating the alkene with mercury 2 acetate, which is HgOAc twice, and water in the first step, which is oxymercuration, to form an intermediate, which is 3-membered mercurinium ion, which is a non-classical carbocation. And then it followed by reduction with sodium borohydride, NaBH4, in the second step, demercuration, to replace the mercury group with hydrogen. So this reaction involves 2 steps. First, oxymercuration, and then demercuration. So here we can see how the double bond is replaced by the hydroxyl group and hydrogen atom. This reaction follows Markovnikov rule. How? Because the OH group is added to the more substituted carbon of the double bond. I hope this is clear to you. If this is clear, then please send me a thumbs up in the chat. Now we are going to learn about hydroboration oxidation reaction. So in this reaction, diborane, that is B2H6, reacts with alkene to produce trialkyl boranes as an addition product. So alkenes react with diborane, which is B2H6, to produce trialkyl boranes. It is an addition product. This trialkyl borane intermediate is then oxidized to the final alcohol product using hydrogen peroxide, which is H2O2. Hydrogen peroxide is H2O2 in the presence of an aqueous sodium hydroxide solution. So this entire two-step process is known as the hydroboration oxidation reaction. So this reaction also involves two steps. First step is the formation of trialkyl borane, and then the oxidation of this trialkyl borane to alcohol using hydrogen peroxide. It happens in the presence of aqueous sodium hydroxide. Now let's have a look at the reaction. So we can see how 3-methyl butane is undergoing this hydroboration oxidation reaction to form the alcohol. The alcohol that is formed during this reaction appears as it was created by adding water to the alkene, in a way opposite to the Markovnikov's rule, that is, it follows anti-Markovnikov's rule. The hydroxyl group, OH groups, gets attached to that carbon which contains more number of hydrogen. So this is anti-Markovnikov rule. It results in the formation of primary alcohol here. Continuing our discussion on preparation of alcohols. So till now we discussed the preparation of alcohol from alkene. Now we are going to see the second method, which is preparation of alcohol from aliphatic primary amines. Aliphatic primary amines react with nitrous acid, that is HNO2, to give primary alcohol. It is a straightforward reaction that converts the amine group into a hydroxyl group. So NH2 group will be replaced by hydroxyl group. So let's see how it works. First, we generate the nitrous acid by reacting sodium nitrite with hydrochloric acid at a low temperature between 0 and 5 degrees Celsius. So HNO2, which is nitrous acid, is produced in C2 using NaNO2 and HCl, because HNO2 is very unstable. Then the primary amine, which is represented by RNH2, it reacts with the nitrous acid present in the C2 to produce the alcohol, ROH. This reaction also involves the liberation of nitrogen gas N2 and water H2O. This reaction is often characterized by the rapid evolution of nitrogen gas. So we can see how we are converting primary amine to primary alcohol. So our final preparation method for alcohol is from Grignard reagent. So the process involves two steps. First, the Grignard reagent. It is represented by R'-MgX. It reacts with either an aldehyde or ketone which contains carbonyl group. And then second, we perform a hydrolysis step with water or acid to convert the intermediate into the final alcohol. Specifically, if the reacting carbonyl compound is formaldehyde, which has 2 hydrogen atoms attached to the carbonyl, we will get a primary alcohol. So, which alcohol we will obtain depend on the which aldehyde or ketone we have starting. So, if we have formaldehyde, then we get primary alcohol. And if we have other aldehydes, which has 1 hydrogen and 1 R group, then we obtain secondary alcohols. And if we use a ketone, if we start with a ketone has 2 R groups attached to the carbonyl, then we end up with tertiary alcohol with Grignard reagent. So formaldehyde reacts with Grignard reagent to form primary alcohol. And other aldehydes except formaldehyde reacts with Grignard reagent to form secondary alcohols. And ketones with Grignard reagent give tertiary alcohol. Always keep this in mind. So here we can see how carbonyl group is reacting with the Grignard reagent. So in Grignard reagent, R' having partial negative charge and Mg having partial positive charge because of the electronegativity difference. We know Mg is electropositive. Therefore, this difference in polarity is generating. So this R', which is nucleophilic, will attack the electrophilic carbon of carbonyl group to produce the adduct. And after hydrolysis, we get our desired alcohol with MgOHX as byproduct. So now we are going to learn about the chemical reactions of alcohol. So till now we discussed the preparation method of alcohol. Now we'll discuss the reactions of alcohol. Alcohols are quite versatile in how they react. They can act both as nucleophiles and electrophiles, depending on the reaction conditions and the other chemicals present. So this dual reactivity is why we see two major types of bond cleavages in alcohols. So the reaction can involve the cleavage of OH bond, that is breaking of OH bond, or the CO bond. So let's first explore the reactions where the OH bond is broken. This type of reaction demonstrates the acidic nature of alcohol, where the alcohol acts as nucleophile. So reactions which involve cleavage of OH bond, in those reactions, alcohol acts as nucleophile. So alcohol react with active metals which are highly reactive like sodium, potassium and aluminum to yield corresponding alkoxide and hydrogen gas. So here is the equation. As we can see in the equation, two molecules of generic alcohol, that is ROH, is reacting with two sodium atoms to produce two molecules of sodium alkoxide, RO minus Na plus. And one molecule of hydrogen gas is also released. So this is a clear example of alcohol donating its acidic proton. So sodium is able to abstract that hydrogen from the alcohol, producing alkoxide, RO minus, and the Na plus gets attached to that RO minus through allostatic force of attraction, and H2 hydrogen gas is released. Now let's look at the acidity of alcohols. The acidity decreasing in the following order: primary, then secondary, and finally tertiary. This means that primary alcohols are more acidic than secondary alcohols, which are in turn more acidic than tertiary alcohols. Why does this trend occur? It's because an electron releasing group such as alkyl group decreases the polarity of the OH bond. The alkyl groups push electron density towards the oxygen, making it less eager to give up its proton. Since a less polar OH bond is less highly to release proton, this ultimately decreases the acidic strength of the alcohol. So more the number of alkyl groups, the less the acidity of the alcohol. Therefore, the acidity of primary alcohol is highest and tertiary alcohol is least. Now, let's switch our focus to reactions involving the cleavage of carbon-oxygen, that is CO bond. In this type of reaction, alcohol react with hydrogen halides such as HCl, HBr or HI. So HCl, HBr, HI are hydrogen halides. So alcohol reacts with these hydrogen halides to form alkyl halides. This is a substitution reaction where the halogen replaces the hydroxyl group. Here we have the general equation. The general equation shows the hydroxyl group OH of the alcohol being replaced by a halogen X from the hydrogen halide HX, producing the alkyl halide RX and a water molecule. The reactivity of alcohol in this reaction is in the decreasing order of tertiary alcohol, followed by secondary alcohol, and then finally primary alcohol. 3 degree followed by 2 degree followed by 1 degree. So tertiary alcohol undergo this reaction very fast. Continue our discussion on reactions of alcohol. So dehydration of alcohol takes place in the presence of strong protic acid. What are protic acids? They can release proton in aqueous solution. So protic acid such as concentrated sulfuric acid, H2SO4, or phosphoric acid like H3PO4. So dehydration of alcohols occur in the presence of these protic acids. It can also be done in the presence of catalysts such as anhydrous ZnCl2 or alumina Al2O3. So here we have the diagram which shows the general reaction where an alcohol loses a water molecule to form an alkene. So let's look at the rate of this reaction. The relative ease of dehydration of alcohol follows a specific order: 3 degree followed by 2 degree and then followed by 1 degree. So tertiary alcohol undergoes dehydration very fast. So let's see the mechanism of this dehydration. So we are continuing with the discussion. So mechanism of dehydration of ethanol. We are taking the example of ethanol to study the mechanism. So mechanism of dehydration of ethanol involves the following steps. So very first step is the formation of a protonated alcohol. Next is the formation of a carbocation. And final step is the formation of ethene by the elimination of a proton. So first, alcohol will be protonated and then carbocation will be formed. And finally, ethene will be formed by the elimination of proton. So here we have the image which illustrates this 3-step mechanism. So we can see we start with the ethanol and we protonate it. So the OH group converts into OH2 plus, and then this OH2 plus leaves as H2O, resulting in carbocation. And finally, a beta hydrogen gets eliminated to get the ethene to form the alkene, and we regenerate the acid catalyst. We know the catalyst does not get consumed in the reaction, so H plus gets regenerated at the end of the reaction. So this is how we can convert ethanol to ethene through dehydration. We are continuing with the discussion on reactions of alcohol. So now let's discuss the oxidation of alcohols. The oxidation of an alcohol involves 2 specific bond cleavages. It's the formation of a carbon-oxygen double bond with the cleavage of an OH bond and CH bond. So, oxidation of alcohol involves the formation of carbon-oxygen double bond and cleavage of OH and CH bond. So, if we use a strong oxidizing agent like acidified potassium permanganate KMnO4, a primary alcohol can be oxidized all the way to carboxylic acid. This happens in 2 steps. First to the aldehyde and then aldehyde quickly oxidized to the carboxylic acid. So if we use strongly oxidizing agent, then alcohols gets all the way oxidized to carboxylic acid. We cannot isolate aldehyde formed here. But by using other reagents like CrO3, chromium trioxide, or PCC, pyridinium chlorochromate, we can convert the alcohol to aldehyde, which means we can prevent the over-oxidation and we can stop the oxidation at aldehyde only. So PCC, which stands for pyridium chlorochromate, it is a milder oxidizing agent than the strong ones like acidified KMnO4. Because of this, PCC is a better reagent to convert a primary alcohol to an aldehyde, preventing the over-oxidation to carboxylic acid. But in the case of secondary alcohols, it forms ketone in presence of both weak and strong oxidizing agent. We cannot further oxidize ketone to carboxylic acid. So whether we use weak or strong oxidizing agent, secondary alcohols will always form ketones. So basically, the product formation does not depend on reagent in case of secondary alcohols. But tertiary alcohols do not undergo oxidation reaction. So if we use these reagent, we cannot oxidize tertiary alcohols to carboxylic acid. However, if a tertiary alcohol is treated with a strong oxidizing agent such as potassium permanganate, KMnO4, and at a high temperature, a different reaction occurs. So instead of typical oxidation, which involve formation of carbon-carbon double bond and cleavage of OH and CH bond, a cleavage of carbon-carbon, that is CC bond, takes place here. This bond cleavage results in the mixture of carboxylic acid or ketone aldehyde that contains a lesser number of carbon atoms than the original alcohol. So we can see how the starting tertiary alcohol, that is 2-methyl-2-propanol, is treated with strong oxidant using drastic conditions. It leads to the breaking of carbon-carbon double bond and finally resulting in the mixture of ketone and carboxylic acid, acetone and formic acid. Formic acid further decomposed to produce carbon dioxide and water. So we are continuing our discussion on reactions of alcohols. So our final reaction for alcohol involves passing alcohol vapors over heated copper. So here we have the reactions of the alcohol with heated copper. As we can see, the product depends on the type of the alcohol we start with. For a primary alcohol, the reaction is a dehydrogenation reaction forming an aldehyde and hydrogen gas. For a secondary alcohol, it also undergoes dehydrogenation but it forms a ketone and hydrogen gas. While for a tertiary alcohol, a different reaction occurs. Tertiary alcohol undergoes dehydration, not dehydrogenation. It undergoes dehydration to form an alkene and water. So we get aldehyde from primary alcohol, that is 1 degree alcohol, ketone from 2 degree alcohol and alkene from 3 degree alcohol, but we are using the same reagent in all the cases. So the product depends on the type of alcohol we start with. We can either get aldehyde, ketone or alkene. Now we are going to learn about the identification of different alcohols, which are primary, secondary and tertiary alcohols. So we can distinguish between primary, secondary and tertiary alcohols using several tests. The first will be discussed is Lucas reagent. It is a mixture of concentrated hydrochloric acid, that is CONHCl, and anhydrous zinc chloride, that is ZnCl2. So Lucas reagent is a mixture of CONHCl and ZnCl2. When a tertiary alcohol is added to Lucas reagent, that is CONHCl and ZnCl2, it gives turbidity immediately. Turbidity means cloudiness or haziness. So if we treat tertiary alcohols with Lucas reagent, we get immediate turbidity. For secondary alcohols, the turbidity appears more slowly, typically within 5 to 10 minutes. And finally, for primary alcohols, they do not produce turbidity at room temperature. Another important test is the Victor-Meyers test. This is a more complex test involving a series of reactions. First, we convert alcohol to alkyl iodide and then we convert it to nitroalkane, and on reaction of nitroalkane with nitrous acid and followed by base, we get the characteristic color. So this is a complex test which involves a series of reactions that ultimately produces a characteristic color which reveals the type of alcohol. So if we get a blood red color, it indicates primary alcohols, that is 1 degree alcohols was present. And if we get blue color, so it indicates 2 degree alcohols was present. And colorless solution indicates the presence of tertiary alcohols. So that's how we can differentiate between primary, secondary and tertiary alcohol using Lucas reagent and Victor-Meyers test. Now we are going to start with phenols. So here we are going to learn about the structure and preparation of phenol. So what is a phenol? A phenol is an organic compound in which one or more hydroxyl group, that is OH groups, are directly attached to carbon atoms of an aromatic system, such as a benzene ring. The simplest example is phenol itself, the unsubstituted phenol, C6H5OH. Now we know the structure, let's see how we can prepare phenols. So we will discuss some general and important methods for the preparation of phenol. So first important method for preparing phenols start with benzene sulfonic acid. This method involves a multi-step synthesis which starts from benzene and ultimately leads to phenol. So first, benzene is reacted with oleum. What is oleum? It is fuming sulfuric acid for sulfonation, which produces benzene sulfonic acid. So we are converting benzene to benzene sulfonic acid using oleum. And then this benzene sulfonic acid is heated with molten NaOH to convert it into sodium phenoxide. Finally, acidification of the sodium salt, that is sodium phenoxide, with a mineral acid such as HCl give us the final product phenol. So first we have converted benzene to benzene sulfonic acid, and then we have converted this benzene sulfonic acid to sodium phenoxide. And finally, acidification of the sodium phenoxide gives phenol. So here is the visual representation of the reaction involved. So we are starting with benzene, reacting it with oleum, which yields benzene sulfonic acid. Oleum is H2SO4 plus SO3. So we get benzene sulfonic acid, which on further treatment with molten NaOH, it forms sodium phenoxide. And finally, hydrolyzing it, acidifying it, we get phenol. We are going to learn more preparation methods of phenol. The second method for preparing phenol involves starting with diazonium salt. So, an aromatic amine is first converted into a diazonium salt using sodium nitrite and hydrochloric acid. So, first we convert aromatic amine into diazonium salt using sodium nitrite and hydrochloric acid. Sodium nitrite and hydrochloric acid together form nitrous acid, HNO2 in C2. These diazonium salt formed then get hydrolyzed into phenols by simply warming them with water or by treating them with dilute acid. So here is the visual representation of the reaction involved. An aromatic amine, here it is aniline. It is first getting converted to diazonium salt using sodium nitrite NaNO2 and hydrochloric acid HCl, and the temperature is around 273 to 278 Kelvin, that is 0 to 5 degrees Celsius. So we get benzene diazonium chloride, and this diazonium salt is then warmed with water H2O to form the final product phenol, and we get nitrogen gas and HCl as byproduct. Our third and final method for preparing phenol is from cumene. So this process starts with the hydrocarbon cumene, which is isopropyl benzene. So phenol is manufactured from the hydrocarbon cumene. Cumene is isopropyl benzene. So in the first step, cumene is oxidized in the presence of air to form cumene hydroperoxide. This is a radical chain reaction that introduces an oxygen molecule at the benzylic position. So oxidation of cumene in the presence of air to cumene hydroperoxide is a radical chain reaction. Then cumene hydroperoxide that is formed is treated with dilute acid. This triggers a rearrangement and subsequent cleavage of the molecule, which produces both phenol and acetone. So we get phenol and acetone as the final product. So as we can see here, at first cumene is oxidized to cumene hydroperoxide, and then cumene hydroperoxide hydrolyzed to phenol and acetone. So cumene is getting oxidized to cumene hydroperoxide. Peroxide include oxygen single bond oxygen linkage, and this cumene hydroperoxide is hydrolyzed to phenol and acetone. So this is a very important method for preparation of phenol. Always keep this method in your mind. The substrate which is cumene is very important, and all the intermediates formed also is very important. Now we'll discuss chemical reactions of phenols. So we start with electrophilic substitution reactions, which are important type of reactions for phenol. So phenols undergo electrophilic substitution reactions. In phenol, the hydroxyl group, which is OH group, shows two competing electronic effect, which are first strong electron donating resonance effect, that is plus R effect, and a weak electron withdrawing inductive effect, that is minus I effect. The stronger plus R effect dominates the weaker minus I effect, due to which the overall electron density in the benzene ring increases. This makes the ring highly activated and therefore more reactive than unsubstituted benzene for electrophilic substitution reaction. So the presence of hydroxyl group on benzene ring activates it towards electrophilic substitution reaction due to plus R effect. Due to the resonance effect, the electron density significantly increases at the ortho and para position of the ring, while there is not much change at the meta position. So this makes OH group an ortho and para directing group. So OH group is ortho and para directing group because it increases electron density significantly at ortho and para positions of the ring. A common example of electrophilic substitution reaction is nitration. So here we have the reaction where phenol molecule is reacting with dilute HNO3 to form mixture of ortho and para nitrophenol products. So phenol is reacting with dilute HNO3 to form ortho nitrophenol and para nitrophenol. Due to the difference in their hydrogen bonding patterns, ortho and para isomers can be separated by steam distillation. The ortho isomer has intramolecular hydrogen bonding, which makes it more volatile, while the para isomer has intermolecular hydrogen bonding, which increases its boiling point and makes it less volatile. That's why we can separate these ortho and para isomer by steam distillation. When phenol is reacted with concentrated nitric acid, that is HNO3, then the strong activating effect of the OH group combined with the harsh reaction conditions, that is conc HNO3, substitutes all three available ortho and para positions on the benzene ring with a nitro group, and this leads to the formation of 2,4,6 trinitrophenol. So here is the overall reaction. Phenol reacts with concentrated nitric acid to form the final product 2,4,6 trinitrophenol, which is also known as picric acid. So picric acid is 2,4,6 trinitrophenol. Always keep the name of 2,4,6 trinitrophenol as picric acid in your mind. So in picric acid, all the activating position, ortho and para position, have been substituted by nitro groups. So on using dilute HNO3, only one position is getting substituted at a time, either ortho or nitro or para. So we are getting two products while using dilute HNO3. But on using concentrated HNO3, we get picric acid, that is all the activating positions ortho and para are substituted by nitro group because of these harsh conditions. We are going to continue our discussion on reactions of phenol. Another important electrophilic substitution reaction that phenols undergo is halogenation, which is the introduction of halogen atom onto the aromatic ring. In the image, we can see the reaction of phenol with bromine under two different solvent conditions. In the first reaction, phenol is treated with bromine in a non-polar solvent such as carbon disulfide CS2 at low temperature. This results in monosubstitution, forming a mixture of ortho and para bromophenol, in which the para isomer is the major product. In the second reaction, phenol is treated with bromine water, that is bromine in aqueous medium. The aqueous solvent promotes the ionization of phenol to a more highly activated phenoxide ion. This leads to rapid and extensive bromination, forming a white precipitate of 2,4,6-tribromophenol, where bromine has substituted all available ortho and para position. So, when using Br2 in CS2 at low temperature, we get mono-substituted product, that is 2-bromophenol and 4-bromophenol. But when using Br2 in water, we get tri-substituted product, 2,4,6-tribromophenol. So, extensive and rapid bromination occurs in the case of Br2 in water. And to control this reaction, to get a mono-substituted product, we should use Br2 in CS2 solvent, not water. So, get a control product, we should use CS2 as solvent, not water. Moving on to other specific reaction of phenol, first we have coal-base reaction. Coal-base reaction is very important from the exam point of view. In coal-base reaction, phenol is first treated with a base to form more reactive phenoxide ion. This phenoxide ion undergoes electrophilic substitution with carbon dioxide. Carbon dioxide acts as a weak electrophile here. The negative charge on the phenoxide ion makes the benzene ring highly activated for electrophilic attack. Substitution mainly occurs at the ortho position at low temperature. Why? Due to the coordination with the sodium ion. So, the sodium ion coordinates with the oxygen atom of the phenoxide ion and the CO2 molecule. Therefore, we get orthohydroxybenzoic acid, that is salicylic acid, as the main product because of the coordination with sodium ion. So, here is a diagram which shows the complete reaction sequence for coal-base reaction. It shows that phenol reacts with sodium hydroxide NaOH to form sodium phenoxide first, which then reacts with CO2 carbon dioxide under heat and pressure, and subsequently an acidic workup yields salicylic acid, which is 2-hydroxybenzoic acid. So, we get ortho substituted product here, orthohydroxybenzoic acid. So, here we are using CO2 as weak electrophile. This is a name reaction. It is very important. If you have understood this, so please send me a thumbs up in the chat. Now we will continue our discussion on the reactions of phenol. There is another named reaction which is Riemann-Tiemann reaction. The reaction of phenol with chloroform, CHCl3. What is the chemical formula of chloroform? CHCl3. So, reaction of phenol with chloroform in the presence of strong base such as NaOH produces CHO group at the ortho position of the benzene ring. A minor para substituted product is also formed. The reaction is completed with an acidic workup to yield the final product, salicylaldehyde. So, coal-base reaction involves CO2 while this reaction involves chloroform CHCl3 in the presence of NaOH. So, here we have a diagram which provides clear illustration of the Riemann-Tiemann reaction. It shows that phenol reacts with chloroform and NaOH to form an intermediate which is substituted benzyl chloride, and then we get the major product salicylaldehyde from this. So first the NaOH abstract the hydrogen from CHCl3 to form the CCl3 anion, CCl3 negative, and this CCl3 negative undergoes alpha elimination to form CCl2 carbene, dichlorocarbene we get as a electrophile here, and then phenol react with that electrophile to form the intermediate, and on reaction of that intermediate with NaOH we get the salicylaldehyde on acidic workup. So the electrophile in this reaction is dichlorocarbene, CCl2 with a lone pair. So this is a very important to note that electrophile here is dichlorocarbene. This can be asked directly in the exam also. So we are going to continue our discussion on chemical reactions of phenols. Another important reaction of phenol is its reaction with zinc dust. When phenol is heated with zinc dust, a reduction reaction occurs where the hydroxyl group, that is OH group, is removed and replaced by a hydrogen atom. So this results in the conversion of phenol into benzene, which is a simple aromatic hydrocarbon. So here is a chemical reaction. So it shows the transformation of phenol to benzene, that is C6H5OH to C6H6 upon heating with zinc, that is Zn, in which ZNO, that is zinc oxide, is formed as a byproduct. So we can remove the OH functional group, that is hydroxyl group, from benzene using this reduction method, using zinc dust. Another important chemical property of phenol is their susceptibility to oxidation. So when phenol is oxidized using a strong oxidizing agent such as chromic acid, it forms a conjugated diketone called benzoquinone. In this, the hydroxyl group is converted into a carbonyl group. So here we have the reaction which represents the oxidation of phenol to the final product benzoquinone. We can see how the hydroxyl group is getting converted to carbonyl group and we get a conjugated diketone. It is known as benzoquinone. So oxidation of phenol is done using Na2Cr2O7 and H2SO4. Now next is ethers. Here we are going to learn about the structure and classification of ethers. Ethers are a class of organic compound and they are defined by the central oxygen functional group that connects two carbon atoms. So organic compounds having ROR, that is O functional group, are called ethers. So in ether, the two R groups can be alkyl and aryl groups and they may be same or different. When both R groups are same, the ethers are called simple or symmetrical ether. But when the two R groups are different, the ether is called mixed or unsymmetrical ether. This means that the two parts attached to oxygen are not the same. It is like having two different sides on a molecule. So when both R groups are different, the ethers are called unsymmetrical or mixed ether, and when both R groups are same, the ethers are called simple or symmetrical ether. So we have the examples here. First example is CH3OCH3. It is a simple or we can say symmetrical ether because Both R groups are methyl groups. Both R groups are same, which are methyl groups. In the second example, we have a mixed ether, CH3O C2H5. It is a mixed or unsymmetrical ether because one R group is methyl group CH3 and another R group is ethyl group C2H5. So now we are going to learn about the preparation of ethers, how we can prepare ethers. So several general methods are used for the synthesis of ethers and we will explore some of them in detail. The first method we will discuss is the dehydration of alcohols. The dehydration of alcohols occurs in the presence of protic acid such as sulfuric acid or phosphoric acid. In this reaction, the product can be an alkene or an ether. This depends on the conditions used. So, dehydration of alcohol can yield either alkene or ether depending on the reaction condition. So, if we use heat or a strong acid, we get an alkene. But if we use a base or certain reagent, we get an ether. The choice of condition determines which product is formed. So a crucial aspect of this reaction is that product can be either an alkene or an ether depending on the specific reaction condition, especially the temperature and the amount of alcohol used. So here we can see So here we can see at lower temperature the ether is favored. The alcohol is getting converted to ether. C2H5O, C2H5, diethyl ether. But at higher temperature, using H2SO4, at higher temperature we get alkene, not ether. So depending on the reaction condition, we get either alkene or ether. So since we are preparing ethers here, so we should use low temperature to get ether. So dehydration of alcohol should be carried at low temperature to particularly get ether product. So continue discussion on preparation of ethers. Another crucial method to prepare ether is Williamson synthesis. Primary alkyl halides are preferred substrates and reacting with sodium alkoxide give a good yield of the ether product. However, if a tertiary alkyl halide is used, then the alkoxide predominantly acts as a strong base and instead an alkene is formed through an elimination, that is E2 reaction. So only primary alkyl halide when react with sodium alkoxide give ether, while tertiary alkyl halide due to steric hindrance give alkene, because in that case the alkoxide, the OR minus, acts as base instead of nucleophile. So this reaction here shows ethyl bromide reacting with sodium ethoxide. Bromide leaves and ethoxide attacks. Ethoxide here acts as nucleophile because alkyl halide is primary alkyl halide ethyl bromide. This results in the formation of diethyl ether CH3CH2O CH2CH3 and sodium bromide NaBr as byproduct. This is a substitution reaction where an ethoxide group replaces bromine. So if we use a tertiary alkyl halide instead of primary alkyl halide, then only an alkene is obtained, then it means that reaction is an elimination reaction. An alkene is formed by removing a hydrogen and halogen from adjacent carbons. So here we can see that when a tertiary alkyl halide is used, an elimination reaction takes place instead of ether formation because the SN2 attack is not possible on the tertiary alkyl halide due to steric hindrance. Therefore, alkoxide group acts as base here, not nucleophile. So it results in formation of alkene along with NaBr and C2H5OH as byproducts. Conversely, if we use primary alkyl halide Rx, then the reaction yields an ether as the major product. So we can see in the second reaction we are getting alkoxybenzene if Rx is primary alkyl halide. Now we are going to learn about the reactions of ethers. Reactions of ether mainly occur at three sites. First, the lone pair of electrons on the ethereal oxygen. Second, cleavage of the CO bond. Or the third, R group itself in the case of aromatic ethers. So these are the three main sites where reactions of ether can occur. One of the most important reactions related to ether is the cleavage of CO bond. So ethers are the least reactive of the functional group. Why? Because CO bond in ethers are very strong and there is no acidic hydrogen present in ether, and also the lone pair of oxygen is less readily available because of the R groups present there. So ethers are the least reactive of the functional group. The cleavage of CO bond in ethers occurs only under drastic conditions, such as with strong concentrated mineral acids like HI or HBr and high temperature. So only using drastic conditions can lead to the cleavage of CO bond in ethers, otherwise ethers are least reactive. So here we can see that when different type of ethers are heated with hydrogen iodide, they undergo cleavage of CO bond. In this reaction, ether produces an alcohol and alkyl halide as a product. So for the first two reactions, the ethers reacting with HI undergo SN2 mechanism because the carbocation form is unstable. So these ether will undergo SN2 mechanism, not SN1 mechanism, and they will react with HI to form corresponding alcohol and alkyl halide. But in the other two reactions, the last two reactions, we can see that ethers are undergoing SN1 mechanism because it can form stable carbocation. That's why these are going SN1 mechanism and forming corresponding alcohol and alkyl halide. So continue our discussion on reactions of ethers. Another important class of reactions for ethers are electrophilic substitution reactions. In aryl ethers, the alkoxy OR group is an ortho-para directing group and activates the aromatic ring for electrophilic substitution. The lone pair of electrons of the oxygen atom of the OR group is donated to the benzene ring through resonance. So here OR is showing plus R effect. It increases the electron density on the ring, especially at the ortho and para position. Therefore, the presence of OR group activates the aromatic ring towards electrophilic substitution reaction. A common electrophilic substitution reaction for aryl ether is halogenation. So here we have the reaction which shows the bromination of anisole, which forms a mixture of ortho and para bromoanisole, where the para isomer is the major product due to less steric hindrance. So here we can see the mono substitution is happening. So anisole in the presence of Br2 in ethanoic acid undergoes mono substitution and forms mixture of ortho and para bromoanisole. Here para bromoanisole is major product due to less steric hindrance. Another example is Friedel-Crafts alkylation, where an alkyl group is added to the aromatic ring. So here we can see the reaction which shows Friedel-Crafts alkylation of anisole, which reacts with alkyl halide. Example here is CH3Cl, methyl chloride. So here anisole is reacting with methyl chloride, CH3Cl, in the presence of anhydrous AlCl3. Here AlCl3 is acting as a Lewis acid. So when anisole reacts with alkyl halide in the presence of Lewis acid, it forms alkylation product. So this reaction yields the para isomer as the major product. The reason is same, because of less steric hindrance. We are continuing a discussion on reactions of ethers. So aryl ethers such as anisole. Anisole is methoxybenzene, as you have just seen. So it can also undergo Friedel-Crafts acylation. The image shows here that anisole reacts with acyl chloride in the presence of anhydrous aluminum chloride AlCl3, which is a Lewis acid catalyst. This reaction produces both ortho and para substituted product, where the para product is measured due to less steric hindrance from the methoxy group. So anisole is reacting with CH3COCl acetyl chloride to form two products, where the para substituted one is measure product because of less steric hindrance. So aryl ethers can also undergo nitration, which is another type of electrophilic aromatic substitution. So here we have the image which shows the nitration of anisole using a mixture of concentrated nitric acid HNO3 and concentrated sulfuric acid H2SO4. So this is the nitrating mixture, which is HNO3 and H2SO4. So anisole, when reacts with this nitrating mixture, it introduces a nitro group at the ortho and the para position of the aromatic ring, which yields a mixture of ortho-nitroanisole and para-nitroanisole. So similar to acylation, the para substituted product is measured because the large nitro group has less steric interaction with the methoxy group when it is at para position. So when anisole reacts with HNO3 and H2SO4, we get para-nitroanisole as the major product. So that's all about the theory of this chapter. And now we are going to discuss questions. So just give me a minute. So now we are going to discuss questions of this chapter. So our first question is, we have to arrange the following compounds in increasing order of their boiling point. The alcohols given are propane 1-ol, butane 1-ol, butane 2-ol, and pentane 1-ol. We have to arrange these alcohols in the increasing order of boiling point. The given options are propane 1-ol, then butane 2-ol, then butane 1-ol, and finally pentane 1-ol in increasing order. Option B is propane 1-ol, then butane 1-ol, then butane 2-ol, and finally pentane 1-ol in increasing order. Option C is pentane 1-ol, followed by butane 2-ol, then butane 1-ol, and then finally propane 1-ol. And option D is pentane 1-ol, butane 1-ol, butane 2-ol, and then propane 1-ol. So we have to choose the correct increasing order of the boiling point. So students, can you try to solve this question? Answer me in the comment section. What can be the correct option? So the correct option for this question is option A, which is propane 1-ol, then butane 2-ol, then butane 1-ol, and finally pentane 1-ol. So let's discuss the solution. So the first principle is that as molecular mass increases, the boiling point also increases. Because as the molecular mass increases, the number of electrons increases, the temporary dipoles increases, which increase in the van der Waals force of attraction. So with the increase in molecular mass, the boiling point also increases. In isomeric alcohols, with increasing branching and then boiling point decreases. So isomeric alcohols are those alcohols having same molecular formula but different structure. So in isomeric alcohols, if we increase branching, then boiling point of those alcohols decreases. This is because branching reduces the surface area, which weakens the intermolecular forces. So that's why primary alcohols have higher boiling point than secondary ones, and secondary alcohols have higher boiling point than tertiary ones. The reason for this is stronger hydrogen bonding and larger molecular size. So applying these principles to our compounds given in the question, we get this increasing order of boiling point. Propane 1-ol, then butane 2-ol, then butane 1-ol, and finally pentane 1-ol. So moving on to next question. This question asks us to, which of the given alcohols will react most rapidly with concentrated hydrochloric acid, conc HCl, and anhydrous zinc chloride ZnCl2? The given options are A 2-butanol, B 2-methylpropane 2-ol, C 2-methylpropanol, or D 1-butanol. So we have to tell which of the given alcohols will react most rapidly with conc HCl and anhydrous ZnCl2. We know this combination is Lucas reagent. Lucas reagent is combination of conc HCl and anhydrous ZnCl2. So the correct option for this question is option B, which is 2-methylpropane 2-ol. Let's discuss the solution. When an alcohol is mixed with concentrated HCl and anhydrous ZnCl2 in a test known as Lucas test, the reaction follows an SN1 pathway. In an SN1 reaction, we know the rate of reaction depends on the stability of the carbocation intermediate. So, more stable the carbocation, the faster the reaction will be. So, in this example, in this question, 2-methylpropane 2-ol is a tertiary alcohol and it forms a highly stable 3-degree carbocation. When we react 1-degree alcohol with Lucas reagent, at room temperature it produces no turbidity. We get a colorless solution. A 2-degree alcohol reacts more slowly and it typically shows turbidity after 5 minutes. For a 3-degree alcohol, the substitution reaction occurs very rapidly and it causes immediate turbidity in the solution. We will get immediate cloudiness in the aqueous solution when we react 3-degree alcohol with Lucas reagent. Therefore, because a tertiary alcohol forms a stable carbocation, it reacts rapidly with Lucas reagent. So here we have the structure of 2-methyl propanol. We can see it is a 3-degree alcohol. That's why it reacts most rapidly with concentrated HCl and anhydrous ZnCl2. That's why our correct option is option B. Now, the next question is, this question asks about the product of the given chemical reaction as shown is the given image. So here the compound is reacting with NBS in the presence of HNu, and then it is reacting with H2O and K2CO3, and we have to choose the correct product from the given 4 options. The correct option for this question is option A. This compound will be formed. Let's discuss the solution. So the compound given in the question reacts with NBS, that is N-bromosuccinamide, and light, that is HNu, replacing the hydrogen atom next to the double bond with a bromine atom, forming a bromoalkene product. So the NBS in presence of light replaces the hydrogen atom next to the double bond, and it preferentially replaces the less steric hydrogen atom. This reaction follows free radical mechanism, and then we get a bromoalkene product. And this bromoalkene product then react with water H2O and potassium carbonate K2CO3, replacing the bromine atom with a hydroxyl OH group to form the allylic alcohol. So first we get allylic bromination product, and after reacting it with H2O and K2CO3, we get allylic alcohol. Moving on to next question. This question asks for the order of dehydration rates of alcohol, specifically which type of alcohol dehydrates fastest and which dehydrates slowest, based on the given options. So option A is 2 degree, then 1 degree, then CH3OH, and then 3 degree. Or option B is 3 degree, then 2 degree, then 1 degree, then CH3OH, which is methanol. And option C is 2 degree, then 3 degree, then 1 degree, and finally CH3OH. Or option D is CH3OH, then 1 degree, then 2 degree, and 3 degree. So we have to tell the rate of dehydration of alcohol. The correct option for the question is option B, which is 3 degree followed by 2 degree, then 1 degree alcohol, that is primary alcohol, and finally methanol. Let's discuss the solution. So dehydration of alcohols refers to the elimination of water molecule from an alcohol, which leads to the formation of an alkene. So we are eliminating water molecule H2O from the alcohol. So this removal of H2O from alcohol is dehydration of alcohol. And what is the product form? It forms alkenes. When multiple alkene products are possible, the dehydration of alcohols occurs according to Zetsef rule. What is Zetsef rule? This rule states that the major product formed in an elimination reaction is the most substituted and therefore the most stable alkene. So the most substituted alkene will be the major product. In acid catalyzed dehydration, the mechanism involves the formation of a carbocation intermediate. The reaction will proceed through the formation of the most stable carbocation, which is a key step in determining the major product and the rate of the reaction. The rate of dehydration is related to the stability of carbocation. So more stable the carbocation, the faster it will form, and therefore, the faster the overall dehydration reaction will proceed. Since the acid catalyzed dehydration involves the formation of carbocation, therefore, rate of dehydration will depend on stability of the carbocation. The more stable the carbocation, the faster it will form, and therefore, faster the overall dehydration reaction will proceed. Thus, the correct order of dehydration of alcohol is tertiary alcohol, followed by secondary alcohol, then primary alcohol, and finally methanol. This is the correct decreasing order of dehydration of alcohol. So that's all about today's chemistry session. Thank you.
Hello everyone. Good evening. Okay, so today we will cover parabola. Okay, so at first we will look at conic section. What is conic section? Okay, then general equation of a conic section and what is concept of parabola, some definition related to parabola, and then we discuss some result on parabola, and we know that equation of parabola is y square is equal to 4ax. Okay, then we look the position of a point with respect to a parabola, then line and a parabola, what is tangent for a parabola, and equation of tangent in different form. Okay, and then we discuss some result based on tangent of parabola, what is normal for a parabola, equation of normal, and then some result related to normal a parabola. Okay, and equation of pair of tangents, then equation of chord of contact, director circle, and then what is conormal points, and at the last we'll discuss diameter of a parabola. Okay, and then we will practice some question on parabola. Okay, so let's start. Okay, so first of all, what is conic section? Okay, so conic section is the locus of a point whose distance from a fixed point and a fixed line is in a constant ratio. Okay, so we define a conic as a locus of point, and point satisfy a condition that the distance of point from a fixed point and a fixed line is in a constant ratio. Okay, that fixed point is called focus and the fixed line is called directrix, that is L. So let's suppose we have a point P. So the point P, the distance of point P with that fixed point S and the fixed line L, then the ratio is constant. Okay, so if we take the locus of that point P, then we get a conic section. Okay, and that constant ratio is called eccentricity and that is noted by E. So according to the condition on E, we get a different conic section. So if E lies between 0 to 1, then we get ellipse, and if E is equal to 0, then conic is circle. If the if is equal to 1, then the conic is parabola, and if E is greater than 1, then conic is hyperbola. So today we'll discuss a particular case, that is E is equal to 1 when the conic is parabola. So if E is equal to 1, then it means the distance of fixed point, the distance of point P with a fixed point and the fixed line, that is directrix, is equal. That is PS is equal to, if we take the point on a directrix on the line is M, then the distance, a perpendicular distance is M, then PM is equal to PS. Okay, then we get a conic section, that is parabola. Okay, so general equation of conic section is second degree equation, that is ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0. Okay, so this equation represent, so there is two cases. First case is when the focus lies on the directrix, that is the fixed point lie on the fixed line. In this case, we get a pair of a straight line. Okay, and condition is if you make a determinant with the coefficient that a determinant of the that is 3 cross 3 determinant, as the first row is a h g, second row is h b f, and third row is g f c. So if this determinant is equal to 0, then we get a pair of straight line. Okay, now according to the condition on eccentricity, that if e is greater than 1, then the lines will be real and distinct and intersecting at a fixed point. So we get a pair of a straight line, and if e is greater than 1, then that lines are real and distinct and they are intersecting at a fixed point. Okay, second one, if e is equal to 1, then the lines are coincident and passing through a fixed point. Okay, if e is less than 1, then lines are imaginary. Okay, now in case 2, if the focus does not lie on the directrix, okay, in case 1 the focus lie on the directrix, on that case we get a pair of a straight line. And when the focus does not lie on the directrix, in this case we get a circle if a is equal to b and h is equal to 0 and e is equal to 0 and determinant is not equal to 0, and determinant is that is 3 cross 3 order determinant of with the coefficient a h g h b f g f c. So if this determinant is not equal to 0 and the coefficient a is equal to b and h is equal to 0 and e is equal to 0, then we get a circle. Okay, another conic section, that is a parabola. So if h square is equal to ab, first condition, and that determinant is not equal to 0, second condition, and if e is equal to 1, then we get a parabola. Okay, third condition, we get an ellipse if h square is less than ab, determinant is not equal to 0 and e is less than 1. Clear? For hyperbola, if h square is greater than equal to ab, determinant is not equal to 0 and e is greater than 1, in this case we get a hyperbola. Okay, and rectangular hyperbola, if a plus b is equal to 0, determinant is not equal to 0, e is greater than 1 and h square is greater than ab, then we get a rectangular hyperbola. So according to the different condition, my second degree general equation, that is ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0 represent different types of curves. Like it can be pair of straight line according to different condition, and it is parabola if h square is equal to ab and determinant is not equal to 0 and e is equal to 1. Okay, so what is parabola? Okay, so the general definition for a parabola is that the parabola is the locus of point which moves in a plane such that a distance from a fixed point, that is focus, is equal to the distance from a fixed straight line. As eccentricity is 1, so ratio is equal to 1, so we get that ps is equal to, if we consider point pm, that is pm is perpendicular to the line ax plus by plus c is equal to 0 as in the figure. So the distance from the directrix to the point P. So if that distance and the distance with the focus is same, then we get what? Parabola. So parabola is locus of point. So from this figure, point is P, x comma y, and the fixed point is focus, and that point is S. Okay, and the fixed straight line is, that is directrix, that is L, and equation of the directrix is ax plus by plus c is equal to 0. So if the distance of this point from focus is same with the distance of this point from directrix, that is perpendicular distance, then the locus of this point P is a parabola. Okay, so this figure represent the parabola. Okay, so let the coordinate of the focus as x1 y1. Okay, and the line is, the directrix is ax plus by plus c is equal to 0. So how we can get the equation of parabola? So just apply the property as for the parabola, the distance PS and the distance of point, the perpendicular distance of point with the directrix is same. So apply the distance formula, and how we can get a distance of a point to the straight line, and that distance is given by, if the equation of line is ax plus by plus c is equal to 0 and the point is pxy, then distance of this point to the straight line is given by ax plus by plus c mod divided by root under a square plus b square. And by using distance formula, the point P is x comma y and the focus is x1 y1. So by using distance formula, this distance is given by x minus x1 whole square plus y minus y1 whole square under square root. So when we're taking square both side, we get x minus x1 whole square plus y minus y1 whole square is equal to ax plus by plus c whole square by a square plus b square. And from here we get a square plus b square x minus x1 whole square plus y minus y1 whole square is equal to ax plus by plus c whole square. Okay, so this is the equation of parabola, general equation of parabola. Okay, and if this focus S lies on the L, that is means the focus lie on the directrix, then this parabola reduced to a straight line through S and perpendicular to L. Okay, clear? Okay, so now we will discuss some definition related to parabola. So first point is vertex. So what is vertex? So the vertex is the intersection point of parabola and axis. Okay, so the point where the parabola intersecting that axis, and that axis is passes through a focus and that is perpendicular to the directrix. So that is your axis. So where that the point where this parabola intersecting that axis, that point is vertex for the parabola. Okay, what is center? So the point which bisect every chord of the conic passing through it. So if we draw any chord on a conic, then that point which bisect every chord and that chord is passing through that point, then that point is called center. Center is defined for hyperbola and ellipse. We are not defining center for parabola. Okay. Next is focal chord. So what is focal chord? So any chord passing through the focus. Okay. So if we draw a chord, and if that chord is passing through the focus, then that a particular chord is called focal chord. Okay. Next is double ordinate. So double node is a chord. Simply it is a chord, but with a specific property is that this chord is perpendicular to the axis. Okay. So if any chord passing through the focus, then that chord is called focal chord. And if any chord is perpendicular to the axis, then that is called double ordinate. Clear? Next is latus rectum. So latus rectum is a double ordinate. Okay, and that is passes through the focus of parabola. Okay, so the double ordinate that passes through the focus of parabola is called latus rectum. Clear? So a chord passing through the focus is called focal chord. A chord that is perpendicular to the axis is called double ordinate, and the double ordinate that is passing through the focus is called latus rectum. Okay. Next is focal distance. So the distance of a point Pxy from the focus S is called the focal distance of the point P. So we have a point P on a parabola, and if I find the distance of this point to the focus, then that distance is called focal distance. Clear? Okay. So there are different types of parabola. Okay. So first one is y square is equal to 4ax, and this type of parabola is left, that is open to the right. Okay. Second type is y square is equal to minus 4ax, that is open to the left. Next is x square is equal to 4ay, that is open upward, and last is x square is equal to minus 4ay, that is open downwards. Okay, so there are four types of parabola. So let's define all terms for this all four parabola. Okay, so the first is vertex. So the first parabola, y square is equal to 4ax, that is open to the right. So for this, vertex is 0 comma 0, and for second is again 0 comma 0, and same for last two, that is vertex is 0 comma 0. Okay, so the point A is the vertex. Clear? And that the point is the point where the parabola intersecting the axis. Okay, so first two parabola is horizontal parabola, and last two parabola is vertical parabola. Clear? In the first two parabola, the axis is x-axis, and for the last, the axis is y-axis. Clear? Now, focus. So focus of the first parabola for y square is equal to 4x is s a comma 0. Okay, the coordinate of s is a comma 0, and clearly the focus for second is minus a comma 0. For x square is equal to 4ay, focus is 0 comma a, and for the last focus is 0 comma minus a. Okay, as this focus lies on the axis. Okay, so if the parabola is horizontal parabola, then y coordinate is 0, and if it is vertical parabola, then x coordinate is 0. Clear? Now equation of x is, so the first two, for the first two cases, y square is equal to 4x and y square is equal to minus 4x. For horizontal case, the axis is x-axis, and equation of x-axis is y is equal to 0. So equation of x is y is equal to 0 for first two, and for last equation is x equal to 0, as the equation of x is y-axis and equation of y-axis is x equal to 0. Okay, next point is equation of directrix. So equation of directrix for first is x plus a is equal to 0, second x minus a is equal to 0, third y plus a is equal to 0, and fourth y minus a is equal to 0. And eccentricity, as the eccentricity for each parabola is equal to 1, so we get e is equal to 1. This is a basic condition for a conic section to be a parabola. Okay, next, extremities of latus rectum. So when we draw a latus rectum, that is double ordinate, that is passing through the focus, so the point where they intersecting the parabola, that point is given by, for first, a comma plus minus 2a. So above x-axis is intersecting at a point a comma 2a, and below x-axis it is intersecting at a point a comma minus 2a. Clear? For second, minus a comma plus minus 2a. So in above x-axis it is intersecting at a point minus a comma 2a, and below that is minus a comma minus 2a. Okay, and for third, x square is equal to 4aa, 4ay, extremities of latus rectum is given by plus minus 2a comma a, and for x square is equal to minus 4ay, it is given by plus minus 2a comma minus a. Okay, now length of latus rectum. So the length of latus rectum is 4a. Okay, next, equation of tangent at vertex. So a is the vertex for each parabola, and that line that is tangent at that vertex is your axis. If your parabola is horizontal parabola, then axis, the tangent is y-axis. Clear? As in the figure, so that is given by x equal to 0. And if your parabola is vertical parabola, then in this case the tangent is x-axis, and the equation is y is equal to 0. The parametric form, so we can write the equation of parabola by just using a single variable, by just using a single parameter, by using t, and that is, for first, y square is equal to 4ax, it is given by x is equal to 80 square, y is equal to 280. If you substitute this value, this satisfies the equation y square is equal to 4x. This is just a way to represent equation of parabola by just using a single variable. Okay, For second case, x is equal to minus 80 square and y is equal to 280. And for third, x square is equal to 4ay, x is 280 and y is equal to 80 square. And for the last, x is 280 and y is equal to minus 80 square. Clear? Next is result on parabola y square is equal to 4ax. So now we will talk different result based on the parabola y square is equal to 4ax. Okay, that parabola that is open to the right. Okay, so this is the figure of the parabola. Okay, there is latus rectum with extremities as a comma 2a and a comma minus 2a. So LL dash is your latus rectum and this length is given by 4a. The axis is x-axis and the tangent at the point vertex is y-axis. Okay, the vertex is given by 0 and the equation of the directrix is given by x is equal to a. Okay, and the equation of parabola is y square is equal to 4ax. Okay, so first is length of latus rectum. So we can write the length of latus rectum as 2 into harmonic mean of focal segment. Okay, so there is a latus rectum that is LL dash and the focal segment is FL and FL dash. So if we take the harmonic mean of this focal segment and we multiply this by 2, we get length of latus rectum. Okay. Next result, if y1, y2 and y3 are the ordinate of the vertex of triangle inscribed in a parabola. Okay, so we have a parabola y square is equal to 4ax and we inscribe a triangle and we know the ordinate of the vertices of this triangle and that ordinates are y1, y2 and y3. Then we can calculate the area of this triangle by using this ordinate and that is given by 1 by 8a y1 minus y2, y2 minus y3, y3 minus y1. Okay. Next point, for the ends of latus rectum of the parabola. So if there is a latus rectum that is LL dash, for this parabola y square is equal to 4x, the value of the parameter are plus 1 plus minus 1 and the parameter is t. So we can find this value as the ends of latus rectum is a comma plus minus 2a. Okay, and equation of parabola is given parametric form is 80 square and 280. So we can substitute 80 square and 280 as a. So from that we get the value of t as plus minus 1. Okay. Next is position of a point. Okay, so now we have a parabola that is y square is equal to 4x. So the point h comma k with respect to this parabola, it can be lies inside and on the parabola or outside the parabola according to the condition on h1. So we have a equation of parabola that is s, and when we substitute the point hk on the equation of parabola we get s1. So according to this s1, if s1 is less than 0, then that point lies inside the parabola. If s1 is equal to 0, then the point lie on the parabola, and if s1 is greater than 0, then that point lie outside the parabola. Okay. Now, line and a parabola. So we have a line and we have a parabola. Okay. So let's suppose we have a line y is equal to mx plus c, a line with slope m and intercept c. Okay. And it meets the parabola y square is equal to 4ax in 2 points. So this line meets the parabola in 2 points, in coincident point or imaginary according to the condition on intercept c, point a and slope m. So if c is greater than a by m, then this line meets the parabola in 2 different points. Okay, 2 real different points. If c is equal to am, then the points is coincident, and if c is less than am, then the line doesn't intersect the parabola because the points are imaginary. Okay. Next is length of chord. So when we intersect this line with the parabola, we get a chord. that is intercepted by the line into the parabola, and that length is given by 4 into root under a into 1 plus m square into a minus mc by m square. So this is the formula to calculate the length of that chord that is made by the line on the parabola. Okay, so when c is greater than equal to a by m, then that line intersecting the parabola, and it create a chord on that parabola, and that length of that chord is given by this formula. Okay, next point, length of the focal chord making an angle alpha with the x-axis. So let's suppose we have a focal chord, a chord that is passes through the focus. So the length of this focal chord that make an angle alpha with the x-axis is given by 4 into a cosec square alpha. Okay, next is, so let's suppose we have a focal chord and T1 and T2 are the end points of this focal chord of the parabola y square is equal to 4ax. Then T1 into T2 is equal to minus 1. Okay, so if there is a focal chord and T1 and T2 are in the parametric form of the end points of this focal chord for a parabola y square is equal to 4x, then it satisfies a condition, that is T1 into T2 is equal to minus 1. Okay, so what is tangent? So as we know, a tangent to a curve is a line that intersecting the curve at a single point. Okay, so a line which intersecting the parabola at a single point, at only one point, then that line is called tangent to that parabola at that point. Okay, so from this figure we draw a tangent at a point P, x1 y1. So we draw a tangent at that point P to the parabola y square is equal to 4ax. Okay, so we can write the equation of this tangent to the parabola in different form. Okay, so first form is the point form. So that is y1 is equal to 2a into x plus x1. So that's how we can write the equation of tangent in point form. Okay, next is slope form, that is y is equal to mx plus a by m. Clear? This is the equation of the tangent in slope form. Clear? Next, parametric form. So parametric form of tangent is ty is equal to x plus at square. Okay. Next, the line y is equal to mx plus c touches a parabola if and only if c is equal to a by m, and as I already discussed, a line is touches the parabola in the coincident point. That means that line is tangent to that parabola if and only if c is equal to a by m. Okay, and the coordinate of the point of contact, that is given by a by m square comma 2a by m. So this, if this line y is equal to mx plus c is a tangent to the parabola, then for this condition is c is equal to a by m, and then the point of contact is given by a by m square comma 2a by m. Okay, so let's discuss some result on tangent. So first, so we have a parabola y square is equal to 4ax and 2 point on a parabola p 81 square 281 and q 82 square 282. So 2 points in parametric form, and so the point of intersection of tangent at 2 points. So we draw the tangent at a point P and at a point Q for this parabola y square is equal to 4x. So the point where this tangent intersecting, the coordinate of that point is given by, that is r, is a t1 t2 comma a t1 plus t2. So clearly the x coordinate is geometric mean of coordinate of p and q, x coordinate of p and q, and y coordinate of r is arithmetic mean of y coordinate of p and q. Okay, so if the tangent at 2 points of parabola intersecting at a point, then the coordinate of that point is given by r, and that is a t1 t2 comma a t1 plus t2. Okay. Next is angle. So where the tangent intersecting, we have a 2 point P and Q on a parabola. P is 81 square 281 and Q is 82 square and 282, and we draw a tangent. Then the point where they intersecting, we create an angle, and that angle is given by tan theta is equal to T2 minus T1 by 1 plus T1 into T2. Okay. Next point, the locus of the point of intersection of perpendicular tangent to the parabola is its directrix. So let's suppose we have a parabola and we draw two tangent on this parabola, and that tangent make it where the point intersecting. So the angle between the tangent is 90 degree. That means they are perpendicular tangent to the parabola. So where they intersecting, that point, when we, so the locus of that point is your directrix. Okay, that means the point of intersection is lies on the directrix. Whenever you get a pair of tangent that are perpendicular tangent, then the intersecting point of the both tangent lie on a directrix. Okay, simple mean. Fourth point, fourth result on tangent. So if the tangent at the point P and Q on a parabola meet T, then ST is the GM between SP and SQ. Okay, so we draw tangent at a point P and Q on a parabola, and that point meet at a point T. So point of intersection is T. Okay, and S is focus of the parabola. So ST is the distance of the focus to the point of intersection. So this ST is the geometric mean of SP and SQ. So P is the point and Q is another point from where we draw the tangent. So the SP is the distance of focus, distance of point through focus, and SQ is distance of a point Q to focus. So ST is geometric mean between SP and SQ. That is ST square is equal to SP into SQ. Okay. Next is, if the tangent and normal at any point P of the parabola intersect the axis at T and G. So let's suppose we have a parabola and we draw tangent and normal at any point P. Okay, and the tangent is intersecting the axis at T and the normal at a point P intersecting the axis at G. Okay, then there is a beautiful relation, that is ST is equal to SG is equal to SP, where S is the focus. That means the distance of focus to the point T is equal to distance of focus to the point G and is equal to distance of focus to the point P. Okay, so if we draw a tangent and normal at a point P on a parabola, and the tangent is intersecting at a point T and the normal is intersecting at a point G, then the distance ST, SG and SP all are same, where S is the focus. Next point, any tangent to a parabola and the perpendicular on it from the focus meet on the tangent at the vertex. So any tangent to a parabola, if you draw any tangent to the parabola and if we draw the perpendicular to that tangent from the focus, then that feet of that perpendicular is meet on the tangent at the vertex. So there if we draw any tangent on the parabola, we just take any tangent on the parabola and then we draw the perpendicular from the focus to the tangent, then the feet of the perpendicular lies on the tangent, and that tangent is drawn at the vertex of the parabola. Okay. Next point, the orthocenter of any triangle formed by three tangent to a parabola lies on the directrix. So if we create a triangle by using the three tangent to a parabola, then the orthocenter for this triangle lies on the directrix. Okay. Next, the length of the subtangent at any point on a parabola is equal to the twice the abscissa of the point. So let's suppose we have point P, x comma y, then the abscissa is x. So the length of subtangent is equal to the twice of abscissa. So the length of subtangent is equal to 2 into x. Okay. Next, two tangent can be drawn from a point to a parabola. So let's suppose we have point. So we can draw the two tangent from that point to the parabola. So these two tangent are real and distinct or coincident or imaginary. It depend on the is the point lies outside, on or inside the parabola. So if the point lies outside the parabola, we can draw the two tangent, two real and distinct tangent to the parabola. If the point lies on the parabola, then we can draw coincident tangents, that two tangent that is coincident. And if the point lies inside the parabola, then we cannot draw the two tangent to the parabola. That is imaginary tangent. Okay. Next is normal. So what is normal? So if we know the tangent and when we draw the perpendicular to that tangent, then that line is normal. So in case of parabola, so a line which is perpendicular to the tangent of the parabola, that is called normal to the parabola. Okay. There are different form of equation of normal to a parabola. First is point form. So that is y minus y1 is equal to minus y1 by 2a x minus x1. This is the equation of a normal of a parabola. Next is slope form, that is y is equal to mx minus 2am minus am cube, cubic equation. Okay, degree is 3. So next is parametric form, that is y plus tx is equal to 2at plus at cube. So these all three are the equation of normals in different form. First is point form, second is slope form, third is parametric form. Now the point of intersection of normals of T1 and T2 are, so if we have 2 point T1 and T2, the parametric T1 and T2 on a parabola, and if we draw the normals at this point T1 and T2, then the point of intersection of this normal is given by this a T1 square plus T2 square plus T1 T2 plus 2 comma minus a T1 T2 T1 plus T2. Okay. So let's discuss some result on normals. First, if the normals at the point P and Q of parabola, let's suppose we have parabola y square is equal to 4ax, and we draw two normal at a point P and Q, and this point lie on the parabola, and they intersecting, these two normal intersecting at the third point R, and that lie on a curve, then the product of ordinate of P and Q is 8a square. Okay, simple result. Next, normal at the ends of the lattice rectum. So we have a parabola, we have a lattice rectum, and we draw the normal at the end of the lattice rectum, that is at the point a comma 2a and at a point a comma minus 2a of the para y square is equal to 4x. Then they meet at a right angle on the axis. That means the intersecting point is on the axis and the angle is a right angle. Okay. So tangent and normal. So we have a lattice rectum of a parabola y square is equal to 4ax, and we draw tangent and also normal at the extremities of this lattice rectum. Then this construct a quadrilateral, and that is square, and the point of intersection being minus a comma 0 and 3a comma 0. That means the when we draw the tangents at the extremities, they intersecting at a point minus a comma 0, and when we draw the normals at the extremities of a lattice rectum, they intersecting at a point 3a comma 0, and they construct a quadrilateral, and that is square. Okay. Next, the normal at any point of a parabola is equally inclined to the focal distance of a point and the axis of the parabola. Okay. Next is the normal drawn at a point P 81 square 281 to the parabola y square is equal to 4x. So if we draw a normal, to a particular point P of the parabola, and that point is at1 square and 2a2. And if this normal we draw, we again made to the another point of parabola, that is Q, at2 square 282, then in this case there is it satisfies some relation, that is t2 is equal to minus t1 minus 2t1, 2 by t1. So if we draw a normal at a point P on a parabola, and if this normal meet again on another point of the parabola, then the parametric satisfies some condition, that is t2 is equal to minus t1 by minus t1 minus 2 by t1. Okay. The normal chord of a parabola at a point whose ordinate is equal to the abscissa subtend a right angle at the focus. The normal chord means we draw a normal at a point, and that normal meet at another point of a parabola, so we get a chord. So this is your normal chord. So if the normal chord of parabola for which the point at a point, we draw a normal chord at a point whose ordinate is equal to the abscissa, that means x is equal to y, then it subtend a right angle at the focus. Okay, then that chord made a subtend an angle on a focus, that is 90 degree. Important result, three normals can be drawn from a point to a parabola. Okay, so from a point we at most can draw three normals. Okay, now pair of tangents. Okay, so let's suppose we have a point P x1 y1, that is external point. So we can draw two tangent to the parabola. Then equation of that pair of tangent, the combined equation, is given by s1 is equal to t square, where s is equation of parabola, that is y square minus 4ax. S1 is when we substitute the point x1 y1 in the equation s, we get s1, that is y1 square minus 4x1, and t is y1 minus 2ax plus x1 tangent. Okay. Next is equation of chord of contact, when these two pair of tangent meet at 2 points of the parabola, and when we join that 2 points we get a chord, that is chord of contact, and the equation of that chord of contact is given by y into y1 minus 2a into x plus x1 is equal to 0. And the equation of chord of a parabola whose midpoint is x1 y1 is t is equal to s1. So we get the equation of t is y1 minus 2ax plus x1 is equal to s1 is y1 square minus 4ax1. So this is the equation of chord of parabola whose midpoint is x1 y1, and the length of the chord of contact is given by I is equal to root under y1 square minus 4ax1 into y1 square plus 4a square by a. Okay, and area of the triangle PAB. So P is the point, that external point, and AB is the point lie on a triangle. If we draw the two tangent from that external point, we create a triangle, okay, with the pair of tangent and chord of contact, and that area is given by y1 square minus 4ax1 whole power 3 by 2 by 2a. Okay, equation of chord joining points P at1 square 281 and q at2 square 282 is given by t1 plus t2y is equal to 2x plus 2a t1 t2. Okay, for PQ to be a focal chord, so for the point PQ to be a focal chord, it must satisfy T1 into T2 is equal to minus 1. Okay, and the length of this length of the focal chord having T1 T2 as end point is given by a T2 minus T1 whole square. Okay, next is director circle. So if we draw perpendicular tangent to a conic, then locus of point of intersection of these two perpendicular tangent is your director circle. Okay, and in a case of parabola, this director circle of parabola is its directrix. Okay, because the point of intersection lie on a directrix and the locus of that point of intersection is directrix. Okay. Next is co-normal points. So what is co-normal points? The points on the parabola at which the normal passes through a common points are called co-normal points. The co-normal points are called the feet of the normal. Okay. So from this figure, the point A, B, C are co-normal point, because if you draw the normal at a point A, B, C on this parabola, these all are meet at a common point, that is P. So A, B, C are co-normal point. So the point on the parabola are called co-normal point. If we draw the normal at this point, they meet at a common point. Okay. Now some properties on co-normal points. First one is the algebraic sum of slopes of the normal at co-normal point is 0. Second, the sum of the ordinate of the co-normal point is 0. And the third, the centroid of the triangle formed by the co-normal points on a parabola lies on its axis. Okay. So if we construct a triangle with the help of co-normal points, then the centroid of this triangle lies on its axis. Next is diameter. So what is diameter? So diameter is locus of midpoint of system of parallel chords of parabola. So if we have a parabola, we draw a different parallel chords of parabola, and when we create a midpoint of the when we create a locus of the midpoint of this system of parallel chords, we get a diameter. Okay. Some result, the tangent at the extremities. So if we have a focal chord and we draw a tangent at the extremities of this focal chord, and that are intersecting at a right angle on the directrix. Okay. So as we know this result, then, and if we create a circle with that focal chord, consider it as a diameter, then that touches the directrix. Okay. So if we have a focal chord and we draw the tangent at the extremities, and the intersection of these two tangent is right angle, and that is on the directrix. So if we create a circle taking that focal chord as a diameter, then that circle touches the directrix. Okay. Second, a circle on any focal radii of a point P, 80 square 280 as a diameter, touches the tangent at the vertex. So if we have a point 80 square 280 and we construct a circle with the help of this focal radii P 80 square 280 as diameter, then that touches the tangent at the vertex, and the intercept of chord of length A root under 1 plus t square on a normal at a point P. Okay. The diameter bisecting chords of slope m to the parabola y square is equal to 4ax is y is equal to 2a by m. Okay. So now we will practice some question. So just wait for a moment. Okay. So first question is, we have to find equation of parabola whose vertex is -1 comma -2. Okay. So vertex is given, that is -1 comma -2, and axis is vertical. So this is vertical type of parabola, and which passes through the point 3 comma 6. Another information is this parabola is passes through a point 3 comma 6. Then What is the equation of the parabola? Options are option A, x square plus 4x plus 28y minus 136 is equal to 0. Option B, x square plus 2x minus 2y minus 3 is equal to 0. Option C, y square plus 4y minus 16x minus 12 is equal to 0. And option D, none of the above. Okay. So try this question. Okay, let's solve. Correct answer is option B, that is x square plus 2x minus 2y minus 3 is equal to 0. The formula that we use, that is equation of parabola whose vertex is a comma b and axis is vertical, that is given by x minus a whole square is equal to 4a into y minus b. Okay, so we just use this equation to find the equation of parabola. So here vertex is given minus 1 comma minus 2. Okay, and axis is vertical, that is parallel to y axis. So the equation should be, as the vertex is minus 1 comma minus 2, that is a is minus 1, b is minus 2. So we get x plus 1 whole square is equal to 4a y plus 2. Okay, so that is the equation of parabola. Okay, so now we have to find the value of a. So as it is given that the parabola is passing through the point 3 comma 6, so 3 comma 6 satisfy the equation of parabola. So just substitute. So we get 3 plus 1 whole square is equal to 4a into 6 plus 2. That is 4 square is equal to 4a into 8. So from here we get 4a is equal to 2. So the value 4a is 2. So just substitute the value 4a into the above equation. We get the required equation of parabola, that is x plus 1 whole square is equal to 2 into y plus 2. So from here we get x square plus 2x minus 2y minus 3 is equal to 0. That is equation of parabola whose vertex is minus 1 comma minus 2, and this type of vertical parabola, and this parabola passes through the point 3 comma 6. Okay. Next question. A focal chord of the parabola y square is equal to 8x in inclined to x-axis at an angle tan inverse 3. Then its length is equal to options 80 by 3, option B 80 by 9, option C 40 by 3, option D 40 by 9. So we have to find the length of the focal chord. For the parabola y square is equal to 8x, and it is given that this focal chord make an angle of tan inverse 3 with x-axis. So just recall the formula of how to find the length of the focal chord with the help of this angle. Okay, so try this. What is the formula for the length? Anyone? Okay, option B. What is the formula? Varsha? Correct answer is option B, 80 by 9. Okay. The formula is the length of the focal chord of parabola inclined in angle alpha with x-axis is given by 4a cosec square alpha. Very good. Okay. So we just need to use this formula to find the length of focal chord. Okay. So there is some trigonometric identity, that is cosec square alpha is equal to 1 plus cot square alpha, and cot alpha is 1 by tan alpha. So as the length of focal chord is 4a cosec square alpha, and it is given that the equation of parabola is y square is equal to 8ax. So when we compare this equation with y square is equal to 4ax, we get 4a is equal to 8. That means a is equal to 2. And alpha is equal to tan inverse 3. So from here we get tan alpha is equal to 3. And as tan alpha is 3, cot alpha is 1 by 3. And cosec square alpha is 1 plus 1 by 3 whole square, that is 1 plus 1 by 9. So length of the focal chord is 4a, that means 4 into 2 into 1 plus 1 by 9, that is 80 by 9. Okay, clear? Next question. Lattice rectum of the parabola whose axis is parallel to the y-axis and which passes through the point 0, 4, 1, 9 and minus 2, 6 is equal to. Okay, options are option A 1 by 2, option B 1, option C 2 and option D none of this. So try this question. In this question we have to find length of the lattice rectum, and the length of lattice rectum is given by, what is the formula for length of lattice rectum? Length of lattice rectum is given by 4 into a. Okay, so we have to find the value of a with the help of equation of parabola, that is parallel, whose axis is parallel to y-axis, and we have to put these points as the parabola passes through this point. So this point satisfies the equation of parabola. We get 3 equations, and when we solve these 3 equations we get the value of a, and from then we calculate the length of lattice rectum. Okay, so use this approach. Okay, let's solve. Correct answer is option A, that is 1 by 2. So length of lattice rectum of parabola is 4 into a. So we need to find the value of a. So let's consider the vertex is b comma c. So the equation of parabola whose axis is parallel to y-axis and vertex is b comma c is given by x minus b whole square is equal to 4a into y minus c. Okay, Now this parabola is passing through the point 0, 4, 1, 9, and minus 2, 6. So substitute this point. You get three equations. So we get b square is equal to 4a into 4 minus c. 1 minus b square is equal to 4a into 9 minus c. And minus 2 minus b whole square is equal to 4a 6 minus c. And when you solve this equation, we get the value of a, and that is 1 by 8. You get 1 by 8. So the length of lattice rectum is 4a, that is 1 by 2. Okay. So try to solve this three question and try to find the value of a, b, and c. And then use the formula 4a. You get the answer. The length of lattice rectum is 1 by 2. Okay. Next question. If the line x minus 1 is equal to 0 is the directrix of the parabola y square minus kx plus 8 is equal to 0, then one of the value of k is option A 1 by 8, option B 8, option C 4, and option D 1 by 4. So here the equation of parabola is y square minus kx plus 8 is equal to 0. And the equation of directrix is x minus 1 is equal to 0. We have to find one of the value of k. Okay. So try this question. What is the equation of directrix for this parabola? Use that equation. Correct answer is option C, that is 4. The formula that we used, the directrix of parabola y square is equal to 4a, x minus h is given by x is equal to h minus a. Okay. So given equation of parabola is y square minus kx plus 8 is equal to 0. So convert into the form of y square is equal to 4ax minus h. We get y square is equal to k into x minus 8 by k. So when we compare this with y square is equal to 4ax minus h, x minus h, we get 4a is equal to k, that is a is equal to k by 4. And equation of directrix is x is equal to h minus a. So we get x minus h, that is 8 by k, is equal to minus a, that is minus k by 4. Okay. So from here we get x is equal to 8 by k minus k by 4 is equal to 1. As x minus 1 is equal to 0 is the directrix, so we get x is equal to 1. So from here when we compare this both equation, we get x is equal to 8 minus k by 4 is equal to 1. So when we solve 8 by k minus k by 4 is equal to 1, we get k square plus 4k minus 32 is equal to 0, and quadratic equation with variable k. And when we solve this quadratic equation for k, we get minus 8 of 4. So one of the value of k is 4. Clear? Next question. The locus of trisection point of any double ordinate of the parabola y square is equal to 4ax is options: y square is equal to 9ax, option B y square is equal to ax, option C 9y square is equal to 4ax, and option D, none of these. Okay, so try this question. So draw this figure. We have a parabola y square is equal to 4ax, and then draw a double ordinate. Trisection point means it divide the double ordinate into three parts. That means that point divide the line in the ratio of 2:1 or 1:2. Okay. We use the section formula. Varsha, which option is correct? Okay. So correct answer is option C, that is 9y square is equal to 4ax. So formula that we use for standard parabola y square is equal to 4ax, the parametric equation in terms of parameters t is x is equal to 80 square and y is equal to 280. We know that. And the trisection point, if we consider that point as p alpha comma beta, then it means that it divide the chord into three equal segment. Okay, so let's solve. So let p alpha comma beta be the trisection point of double ordinate, and that double ordinate is AB. Double ordinate means this line is perpendicular. This chord is perpendicular to the axis. Okay, so the point p alpha comma beta trisect the segment. Okay, it means it divide in the ratio 2:1. Okay, now as the double ordinate is perpendicular to the axis, so if the coordinate of A is at square 280 and coordinate of B is 80 square minus 280, so the coordinate of P is alpha is same 80 square, only we have to find the value of beta, and to find the coordinate beta we apply the section formula. As this point P divide the line AB in the ratio 2:1, so when we apply this formula we get beta is equal to 2 into 280 plus 1 into minus 280 by 3. So from here you get beta is equal to 2 by 380, and then t is equal to 3 beta by 2a. Okay, so substitute this value of t into alpha, we get alpha is equal to a into 3 beta by 2a whole square. So from here we get 9 beta square is equal to 4a alpha, that is the relation with on alpha and beta, so that we get the locus of this trisection point. We just need to replace alpha and beta by x and y. So the locus of this point P is 9y square is equal to 4ax. Okay. Next point. Let O be the next question. Sorry. Next question. Let O be the vertex and Q be any point on the parabola x square is equal to 8y. Okay. So the vertex of this parabola is O and Q be any point on the parabola x square is equal to 8y. Okay. If the point P divide the line segment OQ internally in the ratio 1:3, then the locus of P is. Similar type question. So there is a vertex O and there is only point Q. We join O and Q, we get a line segment OQ, and there is any other point P, that divide this OQ internally in the ratio 1 is to 3. So we have to find the locus of P. Okay, equation of parabola is x square is equal to 8a in this case. So which option is correct? Option A, x square is equal to y. Option B, y square is equal to x. Option C, y square is equal to 2x. And option D, x square is equal to 2y. Okay, so let's solve this question. So correct answer is option D, that is x square is equal to 2y. So section formula for internal division, we know that if we have 2 point A and B, that is x1 y1 and x2 y2, and P, that is xy, divide this line segment AB in the ratio m is to n, then the coordinate of P xy is given by mx2 plus nx1 by m plus n, comma my2 plus ny1 by m plus n. Okay. So we have a equation of parabola is x square is equal to 8y. So any point in the parabola in parametric form, that is 80 square comma 280 is 40 comma 2t square. Okay. Now P divide the line segment the 0 comma 0 as the vertex is origin 0 comma 0, and the point Q is any point that is given by 40 comma 2t square. So when we join OQ, the point P, let the coordinate of point P is h comma k, this divide the line segment OQ in the ratio 1 is to 3. Okay. So when we apply the internal division section formula for this parabola x square is equal to 8a, to find the coordinate P h comma k that divide the line segment OQ in the ratio 1 is to 3, we get h is equal to 1 into 40 plus 3 into 0 by 4, that is h is equal to t. And when we calculate the coordinate k, so k is equal to 1 into 2t square plus 3 into 0 by 4. Okay, and from here we get k is equal to t square by 2, and as t is equal to h, so replace t by h, we get k is equal to 1 by 2 h square. So this is the relation on k and h. So to find the locus, we get 2k is equal to h square. To find the locus of point P, we just replace k and h by x and y. So we get 2y is equal to x square, which is your required locus. Okay. So all clear? So that's all for today. Any doubt? If you have any doubt, you can connect with us on Zoom call on doubt session. Okay. Okay then. Thank you.
Hello students, in today's lecture we are going to learn about ray optics and optical instruments. This is theory part first. This is our disclaimer. So firstly we will see trend analysis of the chapter ray optics and optical instruments in the JEE main examination. So according to last 5 years, the total weightage of this chapter is 3 to 4%. Okay. If we talk about yearly question distribution, so we can say in 2024 question asked from apparent depth prism formula. Number of questions 2. Students, if we talk about their difficulty level, so we can say question was average. In 2023 question asked from mirror formula, power of lens. Okay, number of questions 2. And if we talk about their difficulty level, so we can say one question was easy and one question was average. Similarly, in 2022 question asked from prism formula, number of questions 1, and their difficulty level question was average. In 2021 question asked from real and apparent depth magnification. Okay, and number of questions 1 and their difficulty level average. Similarly, in 2020 question asked from optical instruments, number of questions 1 and their difficulty level average. Okay, so this is trend analysis of the chapter JEE means ray optics and optical instruments. All right, let's see the topics we will cover in today's lecture. Firstly, we will study the reflection of light. Then we will discuss the mirror formula and look at its expression. Then we will discuss refraction of light. All right. After this, we will discuss about refraction through a rectangular slab. Then we will see apparent shift in position of object. Then we will discuss total internal reflection. This is the most important concept for the exam. Then we will study the refraction of light in the case of spherical surfaces. All right. Then we will discuss lens maker formula, which tells us the relation of focal length of a lens with its refractive index and the radii of curvature of its curved surfaces. All right. After all this, we will discuss the topic of refraction by a lens. Then we will discuss power of a lens. Then finally we will study about prism. Okay, so what a prism is and how it deviates the path of light. Okay, we will discuss all about in the concept of refraction through a prism. So these are the concepts which we will discuss in today's lecture. All right, everyone. So first we have reflection of light. Okay, think about it. Basically, reflection of light is a phenomena in which when light strikes a smooth surface and after striking returns to the same medium, we call it reflection of light, as also represented in the figure. Look at here. So here we will understand the reflection of a light. Okay, so this is a smooth surface, or we can say this is the mirror. All right. So when a light known as incident ray, when a light incident on a mirror, or we can say incident on a smooth surface. Okay, and when light strike on the smooth surface, it will reflects in different direction. Okay, so after striking, light returns to the same medium. All right. So when this phenomena is happens, so there is a two angles: angle of incidence and angle of reflection. Okay. So as shown in the diagram, there is a plane mirror and a ray is incident on this plane mirror. So we have named this ray as a incident ray. Okay. So when incident ray reflects from the plane mirror as shown in the diagram, then the ray returns to the same medium after reflection. Okay, and is called reflected ray. I think now this is clear. Yes or no? Anyone having doubt? All right. So there are two laws of reflection, or we can say two laws of reflection of light. So the incident ray, uh, the reflected ray, and the normal, which is drawn on the reflecting surface. Here, look at here. Here, the reflecting surface is a plane mirror. Okay, this is a plane mirror. All meet at the point of incidence. Okay, point of incidence means where the ray hits the mirror. Okay, so according to first law, these three, the incident ray, the reflected ray, and the normal, lie in the same plane. So this is the first law of reflection. All right. The second law is that the angle of incidence, this is angle of incidence, which is formed between the incident ray and the normal. Okay, and it is denoted by angle I. And this angle I is equal to the angle of reflection R. Okay, which is denoted by angle R. So students, the angle of reflection is the angle between the reflected ray and the normal. Okay, so that is angle of incidence I equal to angle of reflection R. All right. So these are the two laws that are that we know as the laws of reflection. All right. Now we will study about reflection by a plane mirror. Or we can so think, or we can say when a ray falls on a plane mirror, okay, at an angle of incidence I, the ray experiences a deviation of angle pi minus 2i. Okay, pi minus 2i. This means that there is a total change in direction of the ray after reflection. So for two plane mirrors inclined at an angle theta, the formula for deviation after reflection of a ray is 360 minus 2 theta. Okay, and this indicates how much the direction of the ray changes after reflecting between the mirrors. Okay, so here two terms is important. First, pi minus 2 into angle I. Second, 360 degree minus 2 theta. All right. So angle theta and here while keeping an incident ray fixed, a plane mirror is rotated about an axis perpendicular to the plane of incidence by an angle theta. Okay, so then reflected ray rotates itself by 2 theta. Okay, and this happens because in reflection the angle of incidence and the angle of reflection are always equal. Okay, so when the mirror rotates, both angle change, due to which the rotation of reflected ray becomes double. All right. Now, if we talk about the focal length and power, so we can say a plane mirror has an infinite focal length and radius of curvature. Okay, this means that it does not converge or diverge rays like curved mirrors do. Therefore, the power of a plane mirror is 0. Okay, or we can say power is reciprocal of focal length. Now, there is a two case when two mirrors are placed at an angle theta. Okay, the number of images denoted by capital N depends on the value 360 degree divided by theta and the position of the object with respect to mirrors. So if we talk about the first case, if 360 degree divided by theta is an even integer, okay, 360 degree divided by theta is an even integer, then the number of images is always 1 less than 360 degree divided by theta. Alright, regardless of where the object is placed between the mirrors. If we talk about an example, okay, so suppose if theta equal to 60 degree, then 360 degree divided by 60 degree is what? It is equal to 6, and that is even integer. Yes or no? So we can say the number of images will be n equal to 6 minus 1, which is equal to 5. Okay. The second case, if 360 degree divided by theta is an odd integer, okay, in that case the number of images depends on the position of the object with respect to the angle bisector. All right, so we can say if the object is placed symmetrically on the angle bisector, then the number of images will be 360 degree divided by theta minus 1. And if the object is placed asymmetrically, that is not on the angle bisector, okay, in that case the number of images will be n equal to 360 degree divided by theta. Clear? So these 2 points are very important. Here we will talk about an example. Suppose if theta is 120 degree, okay, then n equal to what? N will be 360 divided by 360 divided by 120. So when we solving, it will be 3, and which is odd integer. Okay, so if the object is placed symmetrically, then the number of images will be 2, and if object asymmetrically, it will be 3. Okay, clear? Now let's talk about one more case, and this is very important. If 360 degree divided by theta is not an integer, is a fraction, okay, then the number of images is equal to the floor of rotation, floor of that friction. Okay, we can say number of images equal to the floor of that fraction. Okay, floor means what? Floor means the largest integer that is less than that fraction. So suppose if a person stands in the center of the room, okay, and wants to see the full image of the back wall, then the mirror placed on the room's wall should be at least one third the size of the wall. Okay, and this is due to the geometry of light, reflection, and viewing angles. Clear? Now we will discuss sign convention, and this is most important concept for solving numericals. Sign convention, students, plays a very important role in optics because it tells us how distances and heights are to be taken as positive or negative. All right. So according to this convention, we measure distances from the pole of the mirror or the optical center of the lenses. Okay. So look at here. A figure is also given here which provides a visual representation of sign conventions, and we will understand each one by one. All right. So first, when a distance is measured in the direction of incident light, all right, direction of incident light, it is considered positive. And but if the distance is measured in the if the distance measured in the direction opposite to the incident light, okay, then it is considered negative. Clear? So this is the second sign rule of sign convention. Similarly, heights are also measured with respect to the principal axis. Here x axis is the principal axis. Clear? Which is usually the horizontal axis, we can say. So if height is above the x axis, height upwards positive, above the x axis, okay, so we can say upwards in the normal direction to the principal axis, then it is considered positive. And if the height is below the principal axis, okay, then it is given a negative sign. This sign convention helps us to correctly solve problems of reflection and refraction of rays because it gives a clear indication of direction and position. Okay. All right. Therefore, in optics, problems it is a problem. It is very important to assign the correct sign to distances and heights so that we can obtain accurate results. Okay. Any doubt here? So now we will study about reflection from a spherical surface. Okay. Let's see. So a spherical mirror is a part of hollow sphere. It is a small piece one surface of which is polished so that the other surface can become reflecting. Therefore, it is used for reflection. Clear? So the other surface of mirror is made opaque through which light cannot travel. Alright. So let's talk about the image formed by a concave mirror. So look at here, image formed by a concave mirrors. So in the image here, a ray diagram of a concave mirror is shown. Alright. And there is also a table that summarizes the characteristics of images formed by a concave mirror. Okay, this table, this one, this table describes the position, size and nature of the image formed by the concave mirror according to the object's position. Alright, so the characteristics of the image formed by a concave mirror depend on the object's position. Okay, so according to the table here given in the image and several sources, there are different cases and we will discuss each. Alright, so this is the position of the object, position of the image, size of image and nature of image. Okay, so first, object is at infinity. Okay, in that case, image is formed at focus, it is slightly diamondized, okay, or we can say point sized. Nature of the image is real and inverted. Alright, second, uh, object is at infinity. The second is beyond C. Okay, so when object is beyond C, or we can say beyond the center of curvature, image is formed between the focus and the center of curvature C. It is diamondized, real and inverted. Okay, any doubt? The third, at C, position of image at C and size of the image same size. Alright, and nature of the image real and inverted. Similarly, position of the image between C and F. So position of the object is between C and F. The position of the image beyond C. Alright, beyond C. So if we talk about the size of the image, so we can say size is enlarged and nature of the image real and inverted. Alright, at F. So students, image here at F, image is formed at infinity. It is highly enlarged, real and inverted. Okay, and next case, object is between the pole and the focus F. So in that case, image is formed behind the mirror. Okay, it is enlarged and virtual and erect as shown in the table. Alright, so here the image, this one, image shows ray diagrams of a convex mirror and a summary table that explain image formation. Okay, So the first diagram shows here when the object is at infinity, all right, object at the infinity, parallel rays fall on the convex mirror. Okay, so after reflection, the rays diverge and appear to come from the principal focus F behind the mirror. Okay, so the image formed is virtual, erect, highly diamondized, and point sized. Okay, and the second image here, the second diagram shows that when the object is between infinity and the pole P, okay, of the mirror, so the reflected rays diverge but appear to meet at a point between the pole P and the focus F behind the mirror. So in this case, the image formed is virtual, erect, and diamondized. All right. So in the table here, cases of the image formation are given according to the object's position first. Okay. So object at infinity, the position of the image behind the mirror at the focus. Okay, size of the image very small, point size, all right, and nature of the image virtual and erect. Second, object between infinity and pole, all right. So we can say position of the image behind the mirror between pole and focus F, and the size of the image small, diamondized. Okay, and nature of the image virtual and erect. All right. So this is important concept. So there is also a relation between the focal length F and the radius of curvature R of a spherical mirror, which states that the focal length of a spherical mirror is half of its radius of curvature. Okay, for we can say parallel axis, or for parallel rays, that is F equal to R by 2. Okay. So now we will discuss mirror formula. All right. In a spherical mirror, there are some important distances that are necessary to understand image formation. So the first is object distance, denoted by U. Okay, this one, which is the distance of the object from the pole of the mirror. All right. So the pole of the mirror is the point where the mirror's surface is centered. Second, the second is image distance, which is the distance of the image from the pole of the mirror. That is how far the image is formed from the pole is denoted by V. The third important is distance. Third important distance is focal length. Okay, which is the distance of the principal focus from the pole of the mirror. All right. So the principal focus is the point where parallel rays converge or from where they appears to diverge. Okay. So here the important point is first is in case of converse, we can say it will be point focus at a single point. Diverse, it will be spread out. Therefore, we can say the important relation between these three variables u, v and f, that is 1 by v plus 1 by u equal to 1 by f. This means that the sum of the reciprocals of the object distance and the image distance is always equal to the reciprocal of the focal length. Alright? Clear? And this relation is a very important, students. Any doubt here? Yes or no? Alright. This formula is valid for all types of spherical mirrors, concave or convex, and for any position of the object. With the help of this formula, we can easily determine the position of or size of the image. Alright. The next is magnification. Students, magnification means how much larger or smaller an image has become in comparison to the object size. Okay? In simple terms, we can say magnification indicates how much the image size has changed relative to the object size. Clear? So to express this, we take the ratio of the height of the image and the height of the object. We usually denote this ratio by m. So if the height of the object is h and the height of the image is h prime, then we write magnification m using this formula, and that is m equal to height of the image upon height of the object, which is equal to h prime upon h. This means if m is greater than 1, okay, then the image is enlarged. If m is less than 1, then the image is diamondized, and if m is negative, then the image is inverted. Alright. So the magnification is also related to the object distance u and image distance v. So we write this relation as m equal to h prime upon h, which is equal to minus v by u. Here the negative sign indicates that if the image is real, the magnification is negative, and if the image is virtual, students, the magnification is positive. Okay. Now we will discuss refraction of light. What is refraction of light? So look at here. This is the illustration which shows refraction of light. So when a beam of light strikes another transparent medium such as water, glass, etc., okay, some of the light gets reflected back into the first medium, and the remaining light enters the second medium as shown in the figure. So this is our first medium and this is our second medium. Okay. In the figure, a beam of light is represented by a ray of light. Okay. So when a ray of light enters another medium, obliquely, its direction changes at the interface, or we can say at the boundary of the medium. Alright. So this is the here interfaces. Alright. Its direction changes at the interface of the medium. This change of direction is called refraction of light. Clear? So Snell experimentally stated two important laws of refraction, which are follows. First law states that the incident ray, okay, reflected ray, and the normal, okay, which is perpendicular to the interface, at the point where the incident ray falls. All lie in the same plane. Okay, this means these three are in the same flat surface, and this law is somewhat similar to the law of reflection. But there are a reflected ray return to the same medium, and here refracted ray enters the second medium. Okay, this is the second medium. The second law is the ratio of the sines of the incident angle I and the refracted angle R is constant. This means sin I upon sin R is equal to constant. Okay, here I is the angle that the incident ray makes with the normal, and R is the angle we can say that refracted ray makes with the normal. Okay, so this constant ratio is called refractive index, which describes how light travels from one medium to another and how much it will deviate from its path. All right, any doubt? All right. So Snell's law states that when light refracts from one medium to another, okay, there is a two medium, so the ratio of the sine of the incident angle I and the sine of the refracted angle R is a constant, okay, which we call refractive index. So mathematically we can say sin I upon sin R equal to n to 1. All right, here n to 1 is a constant which we call refractive index of the second medium with respect to first medium. Okay, we can also express refractive index in the form of the ratio of the absolute refractive indices. Okay, absolute refractive index is the refractive index of a medium with respect to the refractive index of a air or vacuum. All right, so if n1 is the absolute refractive index of the first medium and n2 is the absolute refractive index of the second medium, then n21 is equal to n2, n21 equal to n2 upon n1. Okay, this one. Here V1 and V2 are the velocities of the light in medium first and medium second respectively. Now here refractive index can also expressed by the ratio of the velocities, and this is very important. Okay, this one. All right, n21 equal to V1 upon V2. V1 is the speed of light in the first medium, V2 is the speed of light in the second medium. Now let's look at the relation of the relative refractive indices for second media when light goes from one medium to another medium and when it comes from the second medium to first medium. When light passes, or we can say when light travels from one medium to another medium, okay, its speed changes. Yes or no? And which is called the refraction of light. All right, clear? So we can say uh, refractive index indicates how much light bends when it crosses from one medium to another medium. Specifically, the refractive index of the medium second with respect to medium first, and that is denoted by n21. Okay, and similarly, the refractive index of medium first with respect to medium second, that is n12. Clear? So these two indices are in a reciprocal relation, that is n12 equal to 1 upon n21. Clear? So what is the meaning? This means that if we need, we can say, if the speed of light slows down, okay, by a certain factor while going from medium 1 to medium second, then while returning from the medium second to medium first, it will be faster by the reciprocal of the same factor. Okay. Now refraction through multiple media. So when light passes through multiple media, let's say there are medium first, medium second, and medium third. Okay, then the refractive index of medium third with respect to medium second is N32. Okay, and the refractive index of medium third with respect to medium 1 is N31. This is for your understanding. All right. So if light travels through different media and returns to the initial medium, listen carefully. If light travels through different media and returns to the initial medium, then the product of the refractive indices for each transition is equal to 1. Okay, and that is n21 into n32 into n31 equal to 1. Here n13 means what? It is the refractive index of medium first with respect to medium third, which is the reciprocal of n31. That is n13 equal to 1 upon n31. Alright. So using this we can also write n32. What is n32? Think about it. So we can say n32 equal to n31 upon n21. Okay. n31 upon n21. Alright. This one. n32 equal to n31 upon n21. Clear? Any doubt here? Yes or no? All right. Good. Now students, we will discuss refraction through a rectangular slab. We have a rectangular slab. Okay. So consider a rectangular slab, rectangular glass slab. Okay. This is the glass slab that is surrounded by a medium first, like air, and medium second, okay, glass. So this diagram shows how refraction occurs when light passes through a rectangular glass slab that is surrounded by another medium like air. This is a basic concept of ray optics. Clear, students? In this process, refraction occurs twice, resulting in the light undergoing a lateral shift, meaning the light beam shifts slightly to the side. So when light enters glass medium second from medium first and then returns to medium first, refraction occurs at two interfaces. Okay. So the first refraction occurs at the air to glass, air to here, air to glass. All right, air to glass interface where light goes from medium first to medium second, and the second at the glass to air interface where light returns from medium second to medium first. So according to laws of refraction, okay, that is Snell's law, we have these relations: n1 sine I1 is equal to n2 sine R1 and n2 sine I2 equal to n1 sine R2. Here I1 is the incident angle in medium first, R1 is the R1 is the angle of refraction in the glass for the refraction at the first interface, and I2 is the angle of incidence inside the glass at the second interface, and R2 is the angle of emergence, okay, when light re-enters medium first. So considering the geometry of glass slab and Snell's law, it is found that R2 equal to R1. This means that the emergent ray is parallel to the incident ray. Okay, therefore there is a no angular deviation. However, the emergent ray gets slightly shifted sideways from the incident ray, which is called lateral displacement, okay, or lateral shift. Look at here, this one, lateral shift, this one. So this means the light beams is in its original direction, but it gets slightly shifted to the side after crossing the slab. All right. So this is our refraction through a rectangular glass slab. Now we will discuss apparent shift in position of object. All right. So when an object is viewed through a transparent medium like water or glass, it appears displaced from its actual position due to refraction of light. Due to this, the depth of the light that we see is different from its real depth. Okay, and the depth that appears to us is instead of the real depth is called apparent depth. Okay, and if the refractive index n21 is higher, then the banding or refraction of light is greater, okay, and due to which the apparent depth becomes smaller. This means the object will appear to be shifted even more upwards. So look at here, this is the visualization of the apparent depth, okay. So this diagram, this one, this diagram illustrates the phenomena of refraction in which light bends, okay. So when an object here is submerged in a dense medium like water, okay, is viewed from a rare medium like air outside. All right, here, then that object appears to be at a position higher or different from its actual place. Okay, let's understand it. So light rays emanating from the object O, okay, which is located deeper in the denser medium, this one, look at here, O. All right. So here O, which is located deeper in the denser medium, travels towards the surface. When these rays enter the rare medium, they bend away from the normal. Okay, they bend away from the normal. All right. The vertical dotted lines, vertical, look at here, these vertical dotted lines This is the normal. Okay. So the observer's eye traces these bent rays in a straight line as shown by dashed lines. Okay. So making these rays appear to originate from a point O prime, which is the above the actual position of the object. Okay. So due to this, the apparent depth always appears less than the real depth when viewed from the rear medium. So because of this effect, we can say here a coin placed in a water or a bottom of swimming pool appears raised. Yes or no? So this is the apparent shift in position of object. So the formula of apparent depth h1 equal to real depth h2 divided by n21. Okay. And apparent shift O prime equal to h2 into 1 minus 1 upon n21. Alright. Clear? Now we will discuss total internal reflection. This is most important concept. Alright. So when light travels from an optically denser medium such as glass or water to a rarer medium such as air, it changes its direction, which is called refraction. Alright. However, when the angle of incidence in the denser medium exceeds a specific value known as critical angle IC, okay, the light does not refract into rare medium but instead completely reflects back into the denser medium, and this process is called total internal reflection. All right. So this diagram explains total internal reflection, or we can say in short TIR. Total internal reflections occurs when two specific conditions are met. If we talk about the first condition, we can say when light travels from an optical dense medium to an optical rare medium. Okay. And the second condition, the angle of incidence I in the denser medium should be greater than the critical angle IC. Okay. So upon fulfillment of these two conditions, light completely reflects back into the dense medium, and this is the phenomenon of the total internal reflection. So here critical angle IC means that particular angle of incidence, that particular angle of incidence where refracted ray travels exactly parallel to the interface in the rare medium. Okay, it means the angle of refraction is exactly 90 degree. If the angle of incidence is less than critical angle, then some lights refracts and some reflects. Okay, but the angle of incidence is greater than critical angle. All right. So in that case, all light energy returns to denser medium in the form of reflection. So there is a relation between critical angle and refractive indices of two media. Sin I is equal to 1 upon n12 is equal to n2 upon n1, which is equal to refractive index of rare medium upon refractive index of denser medium. Okay. So if we talk about the applications, uh, we can say Phoroprism used in binoculars, okay, or billions of diamonds and optical fibers. Now we will discuss refraction at a spherical surface. All right. So when light passes through a curved boundary, specifically a spherical surface, okay, between two media, refraction occurs. And due to this refraction, either a real image or a virtual image is formed. All right, depending on how the light bends. So this figure, this one, this figure illustrates the refraction of light at a single convex spherical surface. Okay, so the figure shows a convex surface separating two media with different refractive indices, N2 denser medium such as glass, N1 rare medium where N2 is greater than N1. Okay, and the center of curvature of this curved surface is at point C2. Okay, and its radius of curvature is R2. A point object is placed at some distance from the surface in the medium N2, which is the source of light rays. Okay, so a ray from the object travels to point A here. All right. So on the curved surface, the line C2 and 2 represents the normal to the surface at point A. C2 and 2. C2. Okay. So when the light rays travels from denser medium to the rare medium, it bends away from the normal. Thus, refraction at a convex spherical surface can form a virtual or real image, which is very important for understanding the basic principle of optics. So there is a relation between object distance u and the image distance v in terms of refractive index of the medium and the radius of curvature of the curved spherical surface r. So n2 upon v minus n1 upon v equal to n2 minus n1 divided by r. Okay, where n1 is the refractive index of the object medium, n2 is the refractive index of the medium where light enters after refraction. And this formula is applicable for any type of curved surface, any image or any position. Clear? So using this equation, we can determine the position of the object and the position of the image. Okay, when light refracts at a spherical surface, radius of curvature r defines the curvature of surface, meaning the smaller r is, the more curved the surface will be and the more it will bend light. So this concept is important. Okay everyone, now we will discuss lens maker formula. This formula relates the focal length f of a lens with its refractive index and the radii of curvature of both surfaces. All right, so when light passes through a lens, the surface of the lens and its refractive index determine how light rays will bend and where the image will form. Okay, so here different images 1, 2 and 3. The diagram shows three scenarios that illustrates refraction of light through curved surfaces. Okay, so in first two diagrams, first one and second one, first two diagrams, refraction at a single spherical surface is shown where light first travels from a rare medium to a denser medium and then travels from a denser to rare medium. Okay, so this results in the final image formation at point I. So the last diagram, third one, this one here, shows a biconvex lens. Okay, which is a combination of two surfaces. Here light comes from object O and after refraction forms a real image I. Okay, at a distance V as shown in the figure. So in which distance, object distance u and focal length are determined based on the lens properties. So the relation between the focal length f of a lens and the refractive index, relative refractive index of the lens and radii of the both surfaces of the lens, that is 1 by f equal to n21 minus 1 into 1 by r1 minus 1 by r2. Okay, n21 is the refractive index of lens with respect to its surrounding material. R1 or R2 is what? This is the radii of radius of curvature of two surfaces. Clear? So this formula is important for designing lenses. Okay, and the difference in curvature determines whether the lens converges or diverges light. Refraction by a lens. So here a lens, a lens is a transparent object which is usually made of glass or plastic and has at least one curved surface. This lens refracts light, causing the light, we can say, uh, causing the light to either converge at a point to appear the diverge from a point. So if we talk about the lens formula, so it will be 1 by f equal to 1 by v minus 1 by u. And we know v is image distance, u object distance, and f is focal length. Using this formula, we can determine where the image will be formed when an object is placed in front of lens. So if we talk about the magnification, so we can say magnification is the ratio between the height of the image h prime and the height of the object h. So magnification can be written as m equal to h prime upon h, which is equal to v upon u. Okay, and we know v is image distance and u is the object distance. So it indicates how much larger or smaller the image is compared to the object. Okay, if m is greater than 1, then the image is larger than object, and if m is less than 1, then the image is smaller. Okay, so if the value of magnification is negative, it means that the image is inverted and real, and in case of positive magnification, the image is virtual and erect. Power of lens. Students, power of a lens measures its ability to converge or diverge light, and it is the reciprocal of focal length. The formula is P equal to 1 by f. Okay. So here the diagram, look at here, this diagram shows the image formation through the combination of two thin lenses L1 and L2. Okay, which are placed in contact. So a point O is placed at some distance u from the optical center P, and the first lens L1 forms an intermediate image at I prime, which acts as a virtual object for the second lens L2. Then second lens forms the final real image at point I, alright, which is at a distance V. Alright, so the combined system behaves like a single lens. So similarly, we can say when two or more thin lenses are placed in contact together, their power are simply added and we get the power of combination. So P effective will be P1 plus P2 plus P3 and so on. And if we talk about their focal length, so we can say effective focal length of thin lenses in contact can be 1 upon F effective equal to 1 upon F1 plus 1 upon F2 plus 1 upon F3. Alright. And its SI unit is diopter. 1 diopter equal to 1 meter inverse. Alright. Clear? And positive power means that the lens is converging, such as a convex lens which converges light rays to a single point. And negative means that the lens is diverging, such as the lens concave lens, okay, which is diverges light rays. Now a refraction through a prism. Students, here a question arises. What is prism? Basically, a prism is a transparent optical element, okay, which is usually made of glass, plastic, or quartz. It has flat and polished surfaces that are arranged at an angle to each other. So the figure here, this one, this figure shows the phenomena of refraction of light through a triangular prism ABC. All right. So let's understand it. Here, a monochromatic light, this one is monochromatic light, rays PQ is incident on the first refracting surface AB with an angle of incidence I. This ray bends towards the normal inside the prism and travels along QR. Okay, travels along QR with an angle of refraction R1. Then this strikes the second surface AC with an angle of incidence R2. Alright, and emerges into the air with, we can say, with an angle of emergence E along RS, where it bends away from the normal. The angle between incident ray PQ and the emergent ray RS is called the angle of deviation. Okay, and angle of prism is denoted by A. Clear? Any doubt here? Yes or no? So it can be used to split a white light into a spectrum of colors, redirect a light beam, or change the image's orientation. So when light enters one side of a prism and exits from the other side, its path changes. Okay, it means the direction of light rays deviates slightly. And students, angle by which the light rays deviates is called angle of deviation. So there is a relation for angle of deviation, that is del equal to I plus E minus A. Okay. And the relation between angle of prism and refraction, R1 plus R2 equal to A. If we talk about the minimum deviation, minimum deviation. Minimum deviation means that particular condition when the deviation of light ray is the least while passing through the prism. Okay. So in this condition, minimum deviation, in this condition, the ray is parallel to the base of the prism which means that the path of the ray inside the prism is symmetrical. Okay, so the here the graph, this graph shows the relation between angle of incidence I and angle of deviation del. Okay, so when light passes through a prism here, as angle of incidence increases from small value, the angle of deviation first decreases. Okay, angle of deviation first decreases. Then uh, we can say reaches as a unique minimum deviation point, del minimum. All right. So after this point, as the angle of incidence increases, angle of deviation starts to increase again, forming characteristic u. Okay, forming characteristic u. So minimum deviation occurs when light ray passes symmetrically inside the prism, meaning the angle of incidence is equal to the angle of emergence I. So I equal to E. This graph is commonly used in physics experiments to determine the properties of prism, such as its refractive index. So condition I equal to E, and here which implies R1 equal to R2, which is equal to A by 2. And angle of deviation becomes minimum, so del equal to dm. So here the formula for refractive index becomes n21 equal to n2 upon n1 is equal to sine A plus dm upon 2 divided by sine A by 2. Okay, this formula is very important. So here for a small angle prism, that is a thin prism, dm is also very small, and we get dm equal to n21 minus 1 into A. All right. Thank you for your attention. Now students, we will solve some practice questions based on these concepts. So are you ready for practice question? Yes or no? All right. Please wait 2 minutes. Hello students. Now we will solve some practice questions based on ray optics and optical instruments. This is practice question part first. This is our disclaimer. Here we will solve some practice questions based on ray optics and optical instruments. So our first question, to get three images of a single object, one should have two plane mirrors at an angle of what? In this question, it is stated that if you have an object and you observe its images through plane mirrors, then you should obtain three images of that object. Okay. Now these images are formed when you have two plane mirrors placed at a specific angle to each other. The question asks what the angle between those two mirrors. Okay, uh, the angle between those two mirrors should be exactly uh, that exactly three images can be formed. So there are four options: option A 60°, option B 90°, option C 120°, and option D 30°. So which option is correct? Please solve. So the correct option will be option B. Okay. Let's see the solution. We have two plane mirrors. Okay, students. So that are placed at some angle theta with respect to each other. Okay. So when we place an object in front of these mirrors, then due to these mirrors, multiple images of that object are formed. Okay. When the angle between the two mirrors is theta, then the formula for the number of images formed is if any 360 if 360 degree divided by theta is an even number. Okay, then the number of images n equal to 360 divided by theta minus 1. Okay, so we are not considering the odd numbers case because it is not mentioned in this question whether the object is placed symmetrically or unsymmetrically. So now it is given in the question n equal to 3 images. Okay, yes or no? So assuming that 360 degree divided by theta is even, so then the formula is 3 equal to 360 divided by theta minus 1. So let's solve this. So when we solving this, you will be get theta equal to 90 degree. This means that the angle between the two mirrors should be 90 degree. Only then we see three images as shown in the figure. Okay. Second question. The maximum magnification that can be obtained with a convex lens of a focal length 2.5 centimeter is what? The least distance of the distant vision is 25 centimeter. Given options: option A 10 centimeter, option B 0.1 centimeter, option C 62.5, and option D 11. So which one is correct? The question asks what what maximum magnification we can obtain uh, with this lens when the object is placed at this least distance. Okay, so this is basically a basic concept of optics where we observe how much an object can be magnified based on the lens's focal length, okay, and the eye's capability. So please solve this question, everyone. You have some time. So the correct option will be option D. Maximum magnification is obtained when the image is formed at the nearest at the eye's nearest point. Okay, that is the least distance of the distant vision. Here the near point is d equal to 25 centimeter. So in the case of image formation by a lens, the formula for magnification m equal to v by u. Okay, v is the what? V is the uh, image distance. So for image forming at near point d equal to 25 centimeter of eye, so v equal to minus d. Here negative sign is for the virtual image because the virtual image is on the opposite side of the lens. Yes or no? So the object distance also negative because the object is on the left side of the lens. So u equal to minus u, therefore the magnification will be m equal to minus d divided by minus u, so it will be d by u. So according to lens formula, 1 by f equal to 1 by v minus 1 by u. So just substitute the values and you will be get some terms, that is 1 by f plus 1 by d equal to 1 by u. So when we simplifying this by multiplying both sides with d, we get d by u equal to 1 plus d by f. So maximum magnification produced by convex lens is given by m equal to 1 plus d by f. Now we have the values, so just substitute here d 25, f 2.5. So when we performing calculation, we will get 11. Okay, so this is our correct answer. Third question. A beam of light composed of red and green rays is incident obliquely at a point on the face of rectangular glass slab. When coming out of the opposite parallel face, the red and green rays emerge from what? Given options: option A, 2 points propagating into different non-parallel directions. Option B, 2 points propagating into different parallel directions. Option C, 1 point propagating into different directions. And option D, 1 point propagating into in the same direction. Okay, please solve this question and find out the correct one. Anyone? Which one is correct? So the B option is correct. All right. So when glass enters a medium, listen carefully. Here a glass slab. Okay, this one. A glass slab. Different colors of light have different speeds in that medium. Therefore, red and green rays are refracted at a different angles inside the glass as shown in the figure. Okay, red and green. This one. So when these rays emerges from the opposite parallel face of the slab, uh, become both the rays become parallel, and this happens because both rays emerges back into the air. Okay, which is the same medium as the incident ray. Therefore, the direction of both rays becomes parallel to the incident ray again. Hence after emerging from glass slab through opposite parallel face, they appear at two different points and move in two different parallel directions because their parallel shifts will be different. Okay. Next question. The optical path of a monochromatic light is same if it goes through 4.0 centimeter of the glass or 4.5 centimeter of water. If the refractive index of glass is 1.53, the refractive index of water is what? Given options: option A 1.30, option B 1.36, option C 1.42, and option D 1.46. So which option is correct? Please solve this question. You have to you have some time. Please solve. D. So the correct option will be option B. Let's see the solution. Optical path length means the distance that light travels in vacuum in the same time. Okay, it takes for it to travel a distance x in a medium with refractive index mu. If the refractive index of a medium is mu and light travels a distance x in that medium, then the optical path length is optical path equal to mu into x. So let's list the values of given in the question, which is given in the question. So mu g equal to 1.53, xg 4 centimeter, xw 4.5 centimeter. Okay, and we have to find out the mu w. All right. So as given in the question, the optical path of monochromatic light is the same if it passes through 4.0 centimeter of glass or 4.5 centimeter of water. This means mu g into xg equal to mu w into xw. So when we substituting the values, we get mu w equal to 1.36. Clear? Next question. On a hot summer night, the refractive index of air is smallest near the ground and increases with the height from the ground. when a light beam is directed horizontally as it travels the light beam. This question asked in JEE in 2015. Okay, so given options, option A becomes narrower, option B goes horizontally without any deflection, option C bends downwards, and option D bends upwards. So which one is correct? Please solve this question. This question is basically based on the refraction of light and variation of refractive index. Okay, please solve. So the correct option will be option D. Let's see the solution. Students, on a hot summer night, okay, the refractive index of air is lowest near the ground. Okay, and as we go upwards, okay, as we go upwards, the refractive index increases. This means what? This means that the near the ground, less dense rare medium, and in the upper part the air is more dense. Okay, so we can say denser medium. So when light passes through a medium with a lower refractive index and then enters a medium with higher refractive index, light bends towards the normal in its path. Okay, so that is when light enters a denser medium, we know it deviates from its initial direction, and at the interface where incident ray falls, it bends towards the line perpendicular to the interface, or we can say in normal at that point. Look at here, denser to rare away the normal, and rare to denser uh, towards normal. Okay, so now here light beam is traveling in horizontal direction. Okay, so we can understand this as the light beam is going from a rare medium to a denser medium. Okay, uh, with an incidence angle approximately 90 degree. Okay, look at here, angle is 90 degree. So as the light travels upwards, it bend towards the normal due to entering a denser medium. Okay, so but because the light beams was initially horizontal, due to bending towards the normal, the path of light will bend slightly upwards. Therefore, this means the light beam will bend upwards. Okay, which option is correct? Option D. Clear? Yes or no? Any doubt? That's all for the today lecture. Thank you for your attention. In next lecture, we will solve more questions and more concepts. Clear everyone? Thank you for your attention.